Good morning, everyone. Thank you. I know it's the last day after the party and the first session in the morning. And I don't believe it. Full house, full house. Okay, it's my responsibility now. Okay. My name is Waldemar Pera. Yeah, it's Waldemar. I'm born in Uruguay. It's not Voldemar. I know this is the right pronunciation. And my surname is from Italy. So it's natural for Uruguay, mixed from everywhere. Yeah, Spain, Italy. The name is taken from my father that delivered to my grandmother, I don't know where. Don't ask us. Okay, my name is Waldemar Pera, working in VMware. My official role is Virtual Cloud Solution Engineering. I'm working on LATAM, cover LATAM, Latin America. And of course, hablo español, para algunos. And also working like lead network and security architecture to my team. Yeah? What is the idea today? Usually, because I'm born in Uruguay, you do everything in the IT. But normally, I am network and security guy. And now talking about Kubernetes. And Kubernetes, usually for us, is something strange. Nice. Taking my memories when the people talking long years ago, VMware, no, it's not my concern. And now you involved in VMware because necessary. I started to see my first time in VMware because I see a virtual switch in the hypervisor. This is a networking thing, it's my thing. I started measuring there. And the same is Kubernetes. It's no strange. You need working around network and security in this stuff. And who knows the best skill for network security? The network security guys. You. Let's go. If somebody speak Spanish, because I know a lot material information in English, that guys is amazing work. Thanks to Hispano is a YouTube channel. Starting with the EMEA people here, but cross the Atlantic with the Latin America people. And you have a lot meetups, recording, of course, lives. So if something in Spain or speak Spanish, good source for you. And this session is starting because I am very active BMAC speaker in Latam. And starting with the guys in Argentina, told me, okay, Waldemar, we need talking about AVI for Kubernetes. Okay, we're starting with that session. But the people like it too much. So there will be a second session expands beyond AVI, or formerly NSX Advanced Load Balancer, to include other stuff in the portfolio of VMware in the same. With that idea, say, if the people like it, maybe, for other people like it. You are the test. Okay, it's a log content. So I try keep slowly. It's my effort. My tendency is talk too much quickly. It's not bad. And part the discussion into this and the second session. Why? Because the risk is you have too much information. You have a brain for the information, and then doesn't remember nothing. So doesn't matter. This is recording. You have information. I have this path. You need keep and keep. But you have the skill for network and security, skill remain. You need change the mindset for the tools, but not the skills. Starting first one, what is the networking? Yeah, Kubernetes has networking. Yes, of course, has networking, has security, has a lot of things and lot. But the environment is different, so the tools need, say, B2B difference. That is the change. And when you thinking around the, the worker, the cluster, the ingress, come on. Yeah, it's true, we need starting, but try keeping simplicity. Try connect what you know in your past, and try to keep the model equivalent for this world. You try not create something completely new. No. It's connected with something you know in your past. So, starting to see, for example, the portfolio, the VMware around the Kubernetes. When you see that portfolio, you have a lot of things around network security. And that is stuff is all focus. Yes, of course, exist another things, strange things with Git hub, git clone, git push, whatever, continuous delivery, continuous integration. Yeah, it's true. It's good to know because you need to know to extend, understood what is the requirement, for example, for the SecOps, because the Sec exists. But for us, for you, for me, that is the important thing. Starting for the first. Why is put everything tools in this ecosystem for Kubernetes? Where? Okay, believe me, NCX still is there. Why? Because if you're running Kubernetes in your on-premise, you need some infra. Always you need some infra. Nothing lives in the ethereal. Exists in some place. That you go to the public cloud, usually you don't know the infra. Exists, but don't you. But in the on-premise, it's your responsibility. And if it exists, it's possible to you connect with other things in my Kubernetes service. So, NSX is important? Yeah. Second one, you're starting talking about load balancer. Yeah, load balancer. Yeah, but the people say me ingress. Or the people talking about OpenShift is a router. Yes, no router, no IP, no. When you say ingress, routing is a service load balancer. What is the difference? You have level 4, formally server load balancer in Kubernetes, or layer 7, ingress. So in the end, it's a load balancer. So NSX is advanced load balancer, or my friend Abby, for local and global balancer. And above, the question is how to connect that black box inside. You have the pods. You have networking inside that the Kubernetes cluster, the CNI. Similar when you have switching and routing, you have something concept, not the same, but the concept. You have connectivity. And the Kubernetes exists as the Kubernetes networking interface to create that connectivity. That connectivity allows us, for example, to handle who talking with who, like network policy. Similar, like in NSX distributed firewall, handle the connection between VMs to VMs. Similar concept, different tool, but the concept is the same. And going above, it's possible creating something strange things. Thinking in the classic problem, I had 2 data centers, I need to extract the network, I think. But in the Kubernetes don't exist that concept. But for example, exists the cross-cluster connections. Maybe it's possible has an application who has some part the application running on-premise, some part running AWS. Don't talk in Tanzu. This and the second session is Kubernetes flavor vanilla, no Tanzu. Tanzu is for all day. But it's possible combine in the same application different components running in different places. When you have that problem, the first problem for me, what is the connectivity? How connect my on-premise with my AKS, EKS, or whatever flavor for Kubernetes? So Tanzu Service Mesh taking the help for you. First, you don't forward IP packets. You're routing, you forward URLs. Now is API, the leitmotif. And again, similar to distributed firewall, you handle layer 7 rules. It's possible to handle layer 7 rules in the API. Okay, come on. This is my today focus. And this allocate each piece in my focus with different products. What is Antria? Antria is an open source project. Yeah, it's an open source project. Support, sponsored by VMware. But it's open source project. As is today, it's already in CNSCF sandbox, so it's a graduate project. And have combined tools, especially around the Open Virtual Switch. For people you know, Open Virtual Switch was created for Nicira people. Nicira people, if you go in the back, was the beginning, the NCX. So it's in the matrix for us. And has very good things, usually, compared, for example, for IP tables, in the case of the Kubernetes. So around IBS, taking another things are talking about security, not only connectivity basic, allow security, like distributed firewall. I build this solution across every Kubernetes has. It's not only for on-premise, it's not only to this field. Yes, you need to go in detail some case for the public cloud, but it's possible use. Majority public cloud use it. And also, Windows Kubernetes, yeah. Antria is the scenario to Azure when you need Windows Kubernetes. Exists Windows Kubernetes. Yes, the major is Linux, but Windows is still there. And it's cross architecture. It's not only for the traditional Intel. No, you see, you have things, and you have NVIDIA because with the RDM and the Edge problem, the legacy Caswick project now, the VMware Edge orchestrator, whatever, the project now is the same concept because what is delivered Kubernetes in the Edge? You need the Kubernetes of the connection. And when you're starting to see what is included in Antria, you have a lot of tools. I feel no. First, is I have connectivity, I need IP. I need IP, I need delivered IP. It's not static IP like usually. It's more close to DHCP because in Kubernetes, the IP doesn't matter. IP is only the point to connect. The policy is above. It's not dependent on the infra. It's the high level. So you have the handle, IP address delivery. You have security, including right now the same concept in distributed firewall. You grow to the IDS, IPS, starting with IDS. Yeah, thinking. Any concept, you know, NSX distributed firewall, include TP, ATP, wherever, they WRDIs fall in the same track for the Kubernetes. Right now, the network security, ready. IDS, in preview yet. And Go, you have translation because with the P change everywhere, but I have a rule in my legacy firewall handle to connect to the database is a VM. Still, I need a single IP. I thought, okay, how handle this dynamic environment, but show what only face to external things. The same, the possibility to handle multi-connection. Originally, Kubernetes thinking one single connection for each pod. But when you go to, for example, to the telco, you have the management, the control, the user plane, you have multiple, or the more traditional, maybe you have, here, but remember the production and backup, whatever. Sometimes you need more connection. You have that option. And connect with other CNI with like Multus for provide that. Troubleshooting includes flow IP fix. What? Yes. It's possible with Antria taking the flows and go to a flow collector. I see it. BRNI, except today, we still a little small part to connect that with the rest, but it's possible to still see what happened in the flows. If somebody see my before session about the first thing is see to connect. You can protect, you can see. You need first see. Visibility, that is included. And the last is the integration with NCX. Yeah, it's an open source project, yeah. But if you have NCX in the other side, it's possibility taking a connection and, for example, create NCX distributed firewall rule, including things, pods, the rules. The project has a lot of different, I don't go any deeper. The things, you have a control plane, you have data plane. It's handled, this control plane is that is connected with NSX to combine. NSX is only in that case control side, but the data plane is still here in Antria. And you have some concept with like pods. Other thing is the minimal running thing running in Kubernetes. Yeah, the people talking about Kubernetes like containers. Containers is inside the pods. A pod is inside the VM. VM is inside the. In fact, yeah, you're looking at Mamushka, the Russian tools. and say, this is the abstraction, but stop it. You have the control. The details is necessary go, but first, still need in the mind the first clear concept. Concept first. Okay, what is the option? This is the more critical for us. The first, network policy, because it's the way to deliver similar concept and execute firewall inside the Kubernetes pod. So you have control. You have this pod talk with this pod. Why? You don't nothing. Usually, every pod talk with every pod. So your organization in zero trust, you need to take in control of that. So it's the way to put my zero trust idea inside some black box like Kubernetes cluster, CNI network policy. And the other side is go outside by self the interconnection and see the cluster by self, who handle connection, who connected to the cluster, who a lot other thing connection is still expanded with Andrea. Also, when you say you hit this Kubernetes and container pods running for everywhere, change the IP, but I need to go to a database, it's a maybe virtual and maybe physical. I have a classic firewall using IP, like a source to true. It's possible to create an egress source net connection. Doesn't matter the IP of the worker, doesn't matter the IP of the pod. In the external, outside the Kubernetes, you always see the same IP. And maybe this guy expand or reduce the number of the pods. Doesn't matter. You always see the same IP. So it's possible to combine my new Kubernetes cloud native application with my legacy application and infra. And still see, okay, I have the control. Let me more. Additional things. What is Andrea? And let me then explain in the second part about that. The ingress is necessary, a load balancer. And that load balancer, believe me to me, create a directly connection, see in the server pool each pod. And that's important because then in my second part explain, you have some restriction, especially when you try to keep the connection always against the same pod. Yeah? Normally when you use the sticky in the balancer. If you see some structure simplifying Kubernetes, create some mistake in that problem. But with Andrea and Abby, it's possible to see the health directly in each pod. To persist connection is necessary. And Andrea delivered that. And when you see in the big picture that it's possible, I say, combine. Is I am Kubernetes or up the go to my Kubernetes cluster. But maybe I deliver my infra and then combine, and repeat, it's not only Tanzu, this control. And above, it's possible to me, for me, network security, delivery policy, or among my control. It's my decision. It's possible that big picture cluster network policy handle for me, and let network policy inside the pod for developers, or let for the security guy. It's your decision in the organization, but you have flexibility for the option. In the end, that is important thing. Sorry for. It's a single glass idea to handle, doesn't matter, it's VMs or Kubernetes. That is the key. We need try easy. It's not easy, but the only way to handle the security, especially the security in this today world, is try connect the thing and translate the same objectives for the security information when different tools adapt for each environment. These are some pictures when you see from NSX, the cluster, the pods, you see the namespace. It's not exactly the thinking right BRF. It's not exactly the same, but this split the same cluster Kubernetes. And you go to see in detail what is the members of the cluster the Kubernetes. It's possible to create NSX security groups, combines, pods, but you don't know the IP. What do you know the pod? Maybe the tag similar to any security attack? Yeah. In the Kubernetes world, everything is attack. In the public world, everything is attack. In any sex, you have attack. So, what do you prefer? Classify object? Tags. And it's possible included maybe the pod name, wherever. And it's possible to create a trace flow. It's a black box. I don't know where it's running. I don't know what create my DevOps team. But if I need a trace flow, it's possible to create, see the connection inside the pod. We are networking guy. We need see. When you see this concept, maybe this part, the network classic network policy, maybe you prefer deliver to developer, but you have this other external control for us, the infra people. The infra, when they say network infra people, yeah, you have control to the security team. Yeah, it's the same concept, not only for the pods, expand for other things, and especially for the security people. Remember, the same path I walk around VMs, starting to the pods. Right now, you have in Antria layer 7 policies already. Perfect. And now in test preview, the idea is why? Because preview. And then con the IPS and the rest. Yeah. Our path is thinking the same concept to Kubernetes. Of course, we have a second discussion in a few minutes. So, suppose if you like it, you remain. And repeat, si alguien habla español o castellano, también lo hablo, como les dije. Nací en Uruguay, vivo en Chile hace 11 años. I live in born in Uruguay, live in Chile the last 11 years, but I still remember my English sometimes with talking with you. Sorry, my mistakes. Taking. This is a few introduction. So, what is keep in this part one? We need to start involving in the project of the Kubernetes. We are network and security people. It's no involvement today. Maybe tomorrow some people deliver a new application, and when the application has 1 million users running, I don't know what is the security. I don't know the troubleshooting for the good guys. If you know already prepared, we are in a big problem. It's the first step. Thank you. Is still reminder? Follow now the second part. Thank you. Thank you very much. I know it's a new session, but it's the same session. And I see the same people, so thank you. Go to the second part for that session. I'm talking about network and security in Kubernetes or at Kubernetes, inside Kubernetes, to network and security guys. Cover the first part, go to the second part. Who is load balancer service and service mesh? And again, don't fret, take it easy. Who is the idea? Originally, when the CNF defined the Kubernetes, we need to expose the application outside the world. And at that moment was enough just put a TCP port outside. And that service was server load balancer. When you go to Kubernetes, it say service load balancer is a layer 4. It's just a TCP port, usually. But, of course, with the time, it's not enough a layer 4. But, included in the same cluster, it's possible to have different applications. Always seeing, waiting in the same port. How classify who as who is only layer 4 information. So I need a layer 7 information. The concept is starting with the people in Red Hat, with OpenShift, with router, and the CNF say ingress. So sometimes you see back and back in both concepts, but it's the same. Ingress, OpenShift routers talking about a layer 7 load balancer. But it's enough with the load balancer. You have, for example, for us, Contour project, yeah. It's a layer 7 ingress balancer, yeah. But it's enough? Really it's enough? Only handle the layer 7 information? No. You need C traffic. You need handle the IP assigned to the public things. You need handle the elastic way to handle the things. You need a lot requirement for security guys. So it's not enough, that basic concept. You need more things. The same thing you need today for the traditional application. Repeat, the concept is the same, change the environment. Or tagger, or objective does remain the same. You need focus in the target, not in the tools. The tools is deterministic for what is my environment. So your skill and your requirement remain. When you do things, usually, that is true. I have a load balancer. Yeah, ready? No. Above, you need handle. Assign the IP. Define the DNS register for the people see your application. And, of course, something to protect, include the WAF. So, usually, it's an additional tool. Enough? No. Because maybe I need some disaster recovery. So I need handle the global balancer. So you have, when you're thinking, the ingress alone is not enough. What is the concern for us? Yeah, you had a lot of tools in the ecosystem of the open source to provide different tools. Yeah, it's possible. But what is the challenger? Each tool is a silo tool. Who, Google, touch everything, you. And you have time to learn to each open source project to see how connect every project you. You have time? No. Oh, sorry, it's too much quickly. So the idea for us is taking these concepts in a single enterprise, when they say enterprise grade solution. Now, come on. And that is the idea inside NSX Advanced Load Balancer, formerly or friendly known AVI. That guy, remember, yeah? It's a ingress, it's a layer 7, layer 4 load balancer, yeah, ingress cover. Handle the assign the IP for the virtual server, yeah. It's possible to define DNS records? Yeah. Include security, include the WAF in the solution? Yeah. Is it for VMs? Yeah. Is for physical stuff? Yes. Is for public cloud? Yes. Is for Kubernetes? Yes. So it's possible to use the same tools and simplify. And this one, visibility. Real thing. Some months ago, I delivered the session in BMAC Argentina, and a guy for the customer see my session. He said, I see a Waldemar yesterday, yeah, talking about that. So, okay, call to Waldemar for formal presentation for us. And explain this or that for network security team. And when you see the visibility, the deep visibility you have only for power on, nothing special, it's just power on the virtual service. That is maybe, I say, a natural way for VMware in network security. If you see the packet, it's possible always taking a picture. So for us, it's nothing special. It's just the packet throw me, I take and collect information. And when you start to see a lot of information, you see, the guy say, Waldemar, yeah, I handle a lot of answer. It's possible to create some way to deliver this view information to the DevOps teams? I say, no, it's not possible. You must create a read-only user, allow each application owner to see your also details. Because that guy has other tools, tons of observability, and now I don't remember where from. But that is inside the service, not outside the structure. This is the other view needed. So create a read-only view. It's okay. And deliver that user for DevOps, for owner, for application. And forget create report for that guy. That guy see your application running, what happened. And don't talking with you. If see something wrong, the pod is working bad or something. It's more quick to fix the problem. The rich visibility in the AVI NSX Advanced Balancer is a key. Everybody needs visibility. Everybody. If you have the solution ready, go. Who knows something NSX Advanced Balancer? You know? Yeah? No? Perfect. So, introduction. Who is my best friend, Avi? You have in any network security things in VMware, usually it's the same philosophy. Central management control plane, distribute data plane. It's always repeat, the same. You have a central point, a controller. That controller is a VM running where do you want, in your on-premise, in the public cloud, or included in some case in the own VMware Cloud service, SaaS service. It's the place you have the definition, you take in the telemetry, the point you handle and control. But the data plane is delivered in each place you need. It's possible in the on-premise, it's possible in the public cloud, it's possible in the bare metal. Depends the condition, is I move the data place where I need it. But I have a single way to control everything. And ring to handle everyone. You have the possibility, and this is good. What is the requirement for the endpoint to use AVI? An IP. A VM, an IP. A VM, no. Every endpoint with IP address, I can see from the data plane is a chance to deliver my service. Doesn't matter it's VM, doesn't matter it's physical server, maybe, I don't know, a mainframe, a Kubernetes, doesn't matter. So it's the only a single solution to balance everything. It's not only for VMs, it's not only for VMware products. It's the same solution. You have central orchestration, you have elasticity. You need more throughput. You create additional data service engine. If the demand decrease, you go down. So you need pay what I think in 3 years forward. I can pay for what service, more buffer, and what you need more add. Oh, is I have this license allocated to my on-premise, but now I need more service now. Taking my on-premise throughput and move to the public cloud. It's a distributed way. That is elasticity. Resilience, si something is broken, I lost the service. No. This guy is ephemeral, like in a pod. Here is up, waiting for the order to what is my work, taking the information, deliver. If I die, doesn't matter. Create a new one, this is information, I go on. It's no key. You have, and that is possible for by self-protect or use the natural protection in your environment, be it high availability or equivalent in every place. Other one, elasticity. Oh, the automation. It's possible for this guy talking with the DevOps and create the service in automation way. Yeah. Why? Yeah, the idea Kubernetes. The DevOps guy, the application, say, I need in the YAML file some service load balancer. I take in the information and create the service. I need ingress, taking the information. So it's possible to include in the continuous delivery and continuous integration pipe, include the creation of the load balancer. Yeah. So it's my decision is deliver or no that power for the application team. But I have the option. And I have a lot visibility, repeat, a lot, and additional service. Why? When you're talking about security, nothing is static. If you're thinking, okay, I need power on the WAF. Okay, what is starting? For us, if you don't know what application, OSWASP. The top 10 OSWASP is taken for the first protection. I have bot detection. So I need some way to update my security stuff. That is a cloud service. So if you now see NSX a load balancer, please use the cloud service. That a lot, for example, the templates for the WAF for the application, always deliver in that way. Because it's more dynamic, because the security today is nothing static. You need still day by day. So dynamic service updating is included. Kubernetes. Okay. I know official name is NSX Advanced Load Balancer, but everyone, AVI, and the operator still say AVI. Okay, it's the same guy. You have two parts in this, or three parts. One, the same controller, use it. And these two guys, operator, name. Operator is an executing pod inside each Kubernetes cluster. What is the function? These people move a packet. Is a watcher in the API to see when some people say, I need server balancer. Let me. I need ingress. Let me. Capture the request to load balancer and ingress. And this request is sending to the controller to create the virtual server. So network security load balancer need to touch the AVI controller to create a new service for the Kubernetes? No. The guy, when you put kubectl apply -c for whatever, is include something load balancer or ingress, a virtual service created. And has a second part when you handle more than one cluster, and you have some disaster recovery, active, or some application with path A and B, and use similar to direct that information, like a global service load balancer. So you have a second operator, M for multi, to handle that case. So in that case, you don't create a virtual server. You create the rule for global service load balancer. Okay, good. Come on. Who is who? Okay. First thing, usually, include concrete, the ingress controller delivered in the open source project is a pod in the cluster Kubernetes. So when you create, usually contour is an example. You need something inside the cluster pod to run the ingress service. First problem is inside. You compete with the resource with other people. If you need more advanced security stuff, you're starting to grow. So you taking too much resource for the Kubernetes cluster against the VMs. So in our case, it's not inside. Who is the same service engine running a VM, is the same data plane. It's not running, the egress running here, nothing running inside. Only the AKO watcher see what is the request. So if something is wrong here, you still have the possibility to grow and nothing affects your service, and you have split duties in both cases. And these guys, of course, save to Kubernetes cluster or other endpoints. What is the idea? I take in this AV controller, installer, whatever, then I create the cloud, is the mention is the way to interact with the infra from the AV controller. You then create the data plane, the people to talking in the front to the customer in the back with the service. And then you talking with the people handle the Kubernetes, I create the installation for my operator. What is included in the operator? In the operator, you say, that is the AV controller, that is the service engine grow, that is, use that information to connect to the infra and starting to see what happened. And with that, you deploy. This is explanation to Kubernetes vanilla, Tanzu, you have other options. Install with Helm, in short, install the application, the AKO inside the Kubernetes. Doesn't matter, it's the type, but you put the pod for watcher, see what happened inside. And then establish, and I am ready. I am inside the Kubernetes, ready to connect with the controller, waiting the people starting to kubectl minus if something. In that case, when the people go, the developer go and create directly, don't touch with the AVI controller, touch naturally with your Kubernetes cluster, and put your service load balance, your ingress, and what information is sent here to the controller in the cluster, you watch with the AKO what happened. I taking that information, in that information say me maybe the FQDN for the application, maybe tell me what is the port, maybe tell me what is the location. Well, information to define the service. I taking that information, I deliver that information to the controller because I talk with the controller, and the controller create the service. Create the service for example, create the DNS record for the application and create the virtual server to wait to come the user to me. The IP for the application. And the clients go to start and consume. How consume the cluster? Go to the DNS. AVI is a DNS server, yeah. It's possible to surrogate a subdomain to handle, define the record in DNS. Tell to the user who is this name is the IP. Go to the VIP, consume with the service pool, in that case my put, process the information, come back, account to the client. So I see the picture. Nothing strange. It's a load balancer. Customer, server pool, or VIP, VIP, back to server pool, process, come back to me, come back to the client. But it's Kubernetes. Doesn't matter. It's a load balancer. thinking in the concept. Don't go in the rabbit hole too much quickly. Think in the concept. It's just a load balancer. When you go, in this case, when you have more Kubernetes cluster or more sites, you need something multi-site. So you have a multi-cluster operator. Multi because you have more Kubernetes cluster. The concept is very similar. In each cluster, you have the same guy, Eiko, thinking your local service, but you have additional people, another operator, just is a controller, is no data plane. What is the responsibility in the MCO? C is in the YAML file, exist, attack, mark. This application is not only local, needs split, protect. If I see that mark in the request, I take in that mark and not only create a record locally for each DNS, maybe I create a single record with two IP belong, one IP, the VIP in each side, I am DNS server, but the difference, I use my healthy check with the VIP to define is answer with this IP in the A record or no, and I have policy for define this for this country, go to that, or maybe it's internal, go to that IP. So all intelligent stuff in HLSS is you. The guy, DevOps, need mark this application need support in multi-cluster or multi-site or wherever. So it's the same. The concept you have the local load balancer, see here before with the AKO, and now you have the option also with the MCO handle the GSLB, the global service load balancer. But it's a global service load balancer. Yes, the same global service load balancer always you use an NSX advanced load balancer AVI, but now for Kubernetes. The guy in the Kubernetes side needed to know details about that. The guy sent kubectl, create the service, maybe mark the application for multi-cluster, multi-location. That's enough. For us, I need run to create something quickly. No. I create the infra and die zero to automate deliver the service. What is my function? See, happen, is resource good, is resource bad, I have some problem. I don't pick rogue every day running with the people. Okay, everything is way, okay, checking and go what they need, but the infra is lie by itself. Okay, shall I explain it? Okay. What is this strange thing? I talking something special before. Oof, the time is right. What is the thing to preserve for us? What is my talk in backend? You have three options. First option, when you're talking about no port. What's no port? You have some C proxy, an IP table in each node to hear in each node for some pod. Doesn't matter if pod exists or not in the worker. What happened? Sometimes go to this guy and you have a local pod, okay. But sometimes go to the same guy but go to the other pod. So I don't have control, it's locally or remote. Work? Yeah. Especially for layer 4 service? Yeah. But if you need some persistence, layer 7 service, cookie, whatever, doesn't work. It's good, simplified, but doesn't work. Basic UDP service, yeah, but TCP service depends, it's HTTP, whatever, persistent doesn't work. Second part, cluster IP. In that case, you see the pod. You see the IP in the pod is C for the network routing. So I can't go directly to the pod. Problem, I need use IP router. What happened? Usually, in the current world, each cluster has that IP repeat and repeat and repeat. So I need to create a special network for each pod so the automation is not in touch. I need to handle that variable, so it doesn't work. But what is the okay? Because I see the pod, persistent is perfect, work. So I close in this, no. You have the third option with Antria. Antria create, you don't know the IP in the pod, but create a destination NAT here only for this pod, only for this pod, only in the worker where exists the pod. So now my pool, server pool is this IP with this port, and see directly the pod doesn't matter the IP inside the pod. So repeatable Kubernetes cluster definition, only need to see the workers, but you have access to the health in the pod. So my personal preference is that case, but depends you have. In that case, any CNI is supported, but no port local today is only Antria, the part one. Okay, finish because it's in time, sorry. Quickly recite. The big problem now when you have distribute service and need to connect everything in each port. You have a lot of people create application. If people create own rules in all the deliver code program and need to create something new, no, go fast. So the problem is you now move APIs. And that problem create a challenger, service and security, because this guy create own security in our source code. Okay, it's possible running, yeah, but I need security connection, visibility, and compliance. Is each people create in our pod, oh, sorry, yeah. Oh. You're starting to see this problem. Who handled the certificate? Sorry, the certification. Who handled? Expire and expire. What is the rules of security? So, what is the idea? Because I don't have a very good time. You have a handle for that. Tansu service mesh. What is the idea behind that? You have a single small proxy behind each pod to connection in a single way to handle certify, role policy, and everything. And only for information, you have layer 7 information API. Yeah, it's my bad time. No handle very well this time. It's possible combine, yeah, in 2 ports. Use the GA7 to handle where you go. So you have ABI, you have Tansu service mesh, and you have option for everything. Yeah, and your question, I need more time for 3 and 4 parts to everything inside TKGG. And it's enough time for me. Thank you. Sorry. My
Good morning. All right, fourth day, including the day that we registered for this session. I'm thankful that you all are here today. All right, let's quickly move to the next slide. We are going to talk about monitoring critical applications. Can we move to the next slide? Clicker. Well, I don't want to go through this slide. You know this. Let's go to the next slide. Thinking about monitoring critical applications, I just was trying to look for some analogy. What was the most critical thing that happened in the recent past? That reminded me of the days that we were all locked up in our rooms during pandemic, having that small device pulse oximeter, checking blood oxygen level for everything. Was that enough? It wasn't. That is discrete monitoring, isn't it? When for a critical patient, he needs ICU, intensive care unit. So there, the monitoring is continuous. All the vitals of the human body are continuously being monitored. Just like how a human body is one entity with multiple vitals which all need to be continuously monitored, critical applications, when I say critical applications, business critical applications, the downtime of which may cause huge revenue loss, need continuous monitoring. That's what is the session that we are going to cover today. We will move to the next slide. We will skip this. I'll just quickly talk about that. We are from VMware IT. I'm Joyce. With me, I have our observability expert, Majin. We are going to talk about how we have implemented monitoring critical applications within VMware IT. Thankfully, we have the best products at our disposal, and we are the first users of our own products. We call it as customer zero. If we engage in beta phase, and if we are working with the GA version, we call ourselves as customer one. We closely work with R&D. Before any VMware product gets launched here, we test it on scale, on our own environment. All right, so I don't want to just cover this slide, just move on. This is what it is, right? We reveal our joys and success and conceal our pain. I just quickly want to check. You all must be running your IT shops. How many of you have legacy systems, monoliths? You think that's not outdated, not current? Well, I'm surprised. I thought everybody's hand will go up. Same with us too. There are so many legacy systems, either we don't have time to update them, or technology has moved so fast that we are lagging, or it may be funding thing, or it may be just it's running, let us keep it running. So we wrap it around, and make it more and more complicated. With modern business applications which run on hybrid cloud, generally modern enterprises use more than one cloud these days. With private cloud and then multiple SaaS solutions, applications are becoming more and more complex. That is far more true with microservice architecture, where the runtime decisions are happening. So you don't know which is running where. That is a typical situation that an IT admin goes through. But as an user, I don't care. I send a request, I need a response. And I need it. I need high available systems performing best whenever I access any portal or any business critical system. That's what it is. So, as an IT infrastructure administrator, this is what happens. There are so many moving parts. There are constant upgrades and updates. That is for the system that we support, not just that, even for SaaS systems, and there are always compatibility things that we need to look on. Configuration changes happening. That reminds me of one minor configuration change on one of the SaaS system of one of our vendor, where a space got added to config file. That caused hours of downtime and major revenue loss. And diversity of architecture. So what would it lead to? That is what the IT admin says. He says, I'm dealing with something that is outdated. It is not built to scale, and nothing was changed. Even if something has changed, it was just a minor, small space within the config file. That's what IT admin says. Let us see what application owner has to say. Right? Application owner doesn't care. Right? Business is moving so fast, they need everything to be implemented, and they need it as on date, right? Well, here is application owner's point of view. He needs high available system, which is seamlessly scalable. Of course, if it is on containers, that's possible during runtime. He wants low latency and best performing systems, and He doesn't know what is running where. He need to launch it as soon as possible, and if anything goes wrong, infrastructure team is at fault. Tell me what went wrong, right? Now that's the point of view of an IT admin and application owner. Let's move to the next slide. Well, now we from observability team are kind of between application owners and infrastructure admins. I want Majin to cover the challenges as observability engineer here.
Yeah, thanks, Joyce. So let me cover the challenges that we face from the implementation of monitoring or observability, right? So if we just go point by point, one would be, probe conflicts in the sense whether I will be able to deploy a probe or a system to monitor that particular component, right? One of the hurdle is, it's for a reason, would be from the security, regulations. Why do you need to have an agent installed on that particular system? Why cannot you do it remotely? And if you do it remotely, what all holes need to be punched, right, in the firewall? So all these things will come up at the end, because generally what we have seen is monitoring or observability is considered as an afterthought, which should not be the case. It should be a shift left approach, right? It should be at the first, during the development phase itself. We will talk about observability-driven development in a while. So this is one of the challenge. The request comes at the very end moment, and we have to go through the security approvals and all those things if it's a new component that we are going to put into it, right? Okay, next thing is lockdown or legacy systems, which does not let you do anything with respect to instrumentation, or whether there are no hooks to do some proactive monitoring to it. So we call it as black boxes, because once the data enters, or it is completely unaware, or it's not able to provide the state, until it comes out of the system. Okay, so that's the one challenge with the legacy systems that we faced. We are trying to find out workarounds to implement observability in that systems as well. So we have some use cases that we are we are doing some POCs on it, in certain cases, what we can do to circumvent these issues. So develop once, deploy anywhere, right? So as Joyce said, we don't, as an application owner or the monitoring system we don't really know where the workload is deployed, whether it's in local data center or it's in multi-cloud or hybrid. We need to have an approach to tackle all these.
Yeah, and Majin, particularly for public clouds, they come with their own monitoring set. You need a solution which actually can take data from their monitoring systems and integrate at one view, actually.
Yeah, heterogeneous, we have all kinds of system. Okay, so this is one of the key challenge, right? Application owners want to monitor everything. What is everything, right? And what it ends up with, too much of noise. The alerts that are not actionable, and which causes the real actionable, alerts to go below the pile, right? So this is one thing. We need to be judicious of what are really actionable insights, right? So that need to be well defined. We need to work with the system team and the application team. So this requires, few back and forth engagements with them.
That actually, I emphasize the point that I mentioned earlier. Discrete monitoring is about you fire an alert, and based on the alert, you take action. But that doesn't work. Just the volume of data that we have in our system, we have 120,000 events getting ingested every second from our logs.
Yeah, logs.
You can't depend on it. And many times, it's kind of repercussions. The root cause will be something. Some small network blip might have caused hundreds of alerts. And they may be transient, they're non-actionable, they're actually not the root cause. You will need to figure out the root cause, basically. You should be able to correlate everything.
So one hat doesn't fit all. So in that case, one size doesn't fit all. So we need to have multiple tools. That's inevitable, right? So the thing is, if we have different set of tools, how do we converge them to one place, right? Because we cannot have multiple or 15 or 16 screens, to look at and act on, right? So that is one of the challenge. We need to have a single pane where we can converge all these alerts and use as a single pane. And as we have multiple tools, there is a high learning curve, right? the team members should be able to manage and work on those tools. So and these tools keep on changing as well, right? So this is another challenge from the monitoring perspective. Yeah, application and service tracing, because with all our modern distributed microservices architecture, tracing is very important and key, right? So what do you think about observability-driven architecture?
See, it's very important mainly because there are multiple teams at play here. Even if, say, for example, gone are the days when VMware was just selling perpetual licenses. It used to just get logged in our system. It is not like that now. Any end user may be requesting for any subscription anywhere through our partners, through our distributors. Those requests come to us. If anything happens in that transaction, end-to-end transaction flow, there are multiple teams at play there. You will need to stitch everything together. And to be able to do that, you should instrument your code. It is shift left, just like how DevOps started. Observability shouldn't be an afterthought. Yeah. When you're designing the system, you should consider observability, and that's what observability-driven development is all about.
Right. So, but how easy or difficult is to inculcate this culture within the development?
It's very difficult because it's more of a processes and mindset. It's a mindset change basically. It is than the tools. Actually, tools are capable, but if you are addressing monitoring and observability as an afterthought just for compliance sake, then you will not be able to achieve it. I mean, thankfully, we have the ability to instrument existing systems, right? You can make it traceable. You don't need to do major code changes. You need to add libraries and make it observable.
Yeah, so we just went through the key challenges. And this is how it used to look, right? We have multiple solutions. And all these are multiple tools. It's not just like within one tool. So this is how a NOC would look like, right? So you see an alert in one screen. Now the thing is we need to correlate with what happened beneath that, right? So that's another tool. So this is what you call the siloed approach that we used to follow, and this is what we are looking at as the end result, right? So this is where we will have a top-down approach within one pane. Okay, so we start with the very basic high-level view, whether my service is up and running or not. Okay, it shows, okay, it's all fine. Now, how about the performance? What is the response time? Okay, within the limit, all good. Now, if you want to, you can drill down deep into the other stacks or the stacks beneath it, or independent applications or services that we can use with the other widgets. We see we have segregations based on the data centers, and its availability is shown. And what we have done is we'll show it in a demo. We can actually make what you call panels within the dashboard for each of the component, right? And you can just expand it and see how's the state of it. We'll see that in a demo, demo video. So this is, this is the ideal state we should be in. So we don't have to jump across multiple systems. And with that, we will go to a few use cases.
Yep.
Okay. So these are the use cases that we have in our IT environment. So we'll take two use cases.
Should be good to cover 2 use cases.
In the interest of time. So this is a custom dashboard that we have built for monitoring our internal container registry. Okay. So this is a widget. This encompasses the entire architecture or the service. So from the NS1, which is a monitoring service, DNS service, and we have different views for the metrics of our interest, right? So if you see, this is the login response time for login pages from multiple locations. Okay. So how do we do it? For external monitoring, we use a third-party tool, and that is integrated with area operations for applications, and that's how we get this data in.
So we should actually mention about the number of integration that area operations for applications has, right?
Okay.
More than 250.
Yeah, it's the default or built-in integrations are more than 250.
The product that we are talking about is area operations for applications, which we used to call Wavefront, Tanzu Observability before. Now it is called
Tanzu Insights.
Tanzu Insights. Yeah, that's the product that we are talking about.
Okay.
That's our main product for single pane of view for our command center.
And coming down, it is the GTM status for the VIP. So right now it is being served from SE2. And okay, we didn't have this completed, so this is for the VMC data center. So what will happen is if there is a service issue with SE2, it will flip to VMC as the backup data center, and we'll see that this coming up and this turning down.
So, well,
Okay.
each region have multiple data centers.
Yeah.
SE2 is one of our data center. Likewise, we have all the data centers listed there. This whole dashboard is crawlable horizontally and vertically, and then further drill down that Majin is going to show.
Okay. So it's the same widget on the other side. There's a different visualization. Yeah, this is based on the request from external, different locations. And these are the details of the proxy. Or if you see, currently it is being served from SE2 data center. And this is how easily you can create a widget. Okay, let me play this. So this is a metric which determines the state of it. Okay, and it's a kind of a binary, 0 or 1. If it is 0, it is in error state. If it is 1, it's WDC. So it's currently running from SE2. Details with respect to the L1, Nginx proxies, the active connections, request rate, all those details are there. And the file system for these proxies. If you see here, we have 4 nodes, okay? So this is the backup one, backup DR side. It has 2 nodes, and all these, vital informations are shown as small, easily readable widgets, okay? So if you see anything turning red, that requires attention, right? So it gives visual cues to what need to be taken care, and this is our TKG environment. If you see, we have both the SE2 and WDC for each of these components because it's running on a DR state.
The idea is to identify anomaly even before it becomes a major issue. So correlate them together. That's what these graphs are all about.
Yeah, you can see, it's a higher heat source CPU usage on SE2 because this is not actively being used. So you'll see all these parameters being slightly skewed on the SE2 side. Similarly, we have Postgres clusters, both in SE2 and WDC. The parameters of those interest, like buffers, these are specific to Postgres.
In interest of time, can we move to the next use case, Majin?
Yeah, okay, I'll do that. So that was an active standby environment. This is an active. This is being actively served from multiple locations. This is the VMworld, environment that we had last year. So it was called VMworld back then. So again, we have bifurcated based on the components, right, starting from the URLs. Is it not playing? Yeah, so you can see the bifurcation of each component. You can just expand and see what the state of it. We just start with the web page. Within the web page, we have multiple components. How is its availability? This is on a global scale, okay? So for each of the pages, what is the latency? And from external locations, from UK, the US, West and East, how is the response time? Coming to the auth layer. How is it all performing? The load balancers, for each of the service, for the MySQL service, and the controller status for the VIPs, MySQL cluster-related details, how many are active, all those details are shown. So the point is, it's very easy to create custom dashboards. Just that you need to have the data, and we have multiple, options of widgets that can suit the visualization format that you need, right? Okay, so just to close this up, we'll go to the next use case. This is on the tracing part. So this is the application trace map when it says, okay, these are the interlinked applications or services when it comes to tracing. Okay, so this is because we have enabled and instrumented our applications. And if you see, just to start with, we have these 24 applications, and it shows the map of how these are interconnected to each other, right? So it gives a visual cue, which is very important, right? Because things change every now and then. Just seeing it, say, okay, now this is taking a different route, okay? Or it has failed over. So we'll be able to see those, live changes in real time. So this is that application map. Just fast forward it. Okay, so this is the trace browser. If you go deep into the tracing part of it. So these are individual transactions that are happening. Okay, so if you just take this example, right, of authentication happening to the API gateway for my VMware. So this is one of the flow in that system, right? So the hit gets, this auth system gets the hit, and it does a lot of things like validation and authorization. Then it forwards that to the gateway, right? So all these steps that we see are actually the spans that are happening within that service. We didn't have this visibility deep into what is happening within the service, but with traces and instrumentation, we will be able to see what actually is being happened within the scenes and what response time or how it is performing. And if you find a breakpoint there, instead of saying that, okay, this particular service is failed, we will be able to tell which span or which, sub-process in that service is actually causing issues, which is very helpful in troubleshooting and decision making as well.
And mainly the red matrix is going to indicate what is that user might be experiencing. Digital experience monitoring, it's kind of number of requests that you get, how many of those error, and what is the
average
performance,
duration,
average duration that their requests are taking. So this will help us understand overall health of your system.
Right, so this very derived, it is a very key derived metric, request, errors, and duration, right? So with this, we will be able to guess or assess the performance, how it is going on.
Can we cover the takeaway? We just have 2 more minutes.
Yeah, okay. So we have seen, what our challenges were, being dynamic and complex and all those things. We see the challenges with respect to observability. Now with area operations for applications and its surrounding ecosystem, now we have a common metrics and observability platform. Okay, we have dashboards, we have visual indicators, which is easy to navigate at times of need. And other thing is, it has an intelligent alerting engine, right? So instead of gone are the days where we used to set static thresholds, now it can assess the performance or the metric or period of time and come up with dynamic thresholds, right? Which eliminates a lot of transient alerts that happen. And reduce, obviously, the after effect of all this is reduced time to identify,
the root cause.
And isolate the root cause.
Yes.
So these are the...
Yeah, it is not that we have 100% perfect system. No, we don't. It is a moving target. Just because we have such good products, we are able to, probably we are a few steps ahead of the rest of the IT shops.
Yeah. That's it.
Yeah, the key functionality, you need to make sure that your alerts and
It is.
are tagged so that you could build application topology and make sure whatever tool you're using has wide integrations. We talked about area operations for applications, more than 250 integrations, including the monitoring solutions that the public clouds, AWS, GCP, and all provide, and interoperability between all the monitoring tools we have. We in fact stopped looking for one-stop solution. We also have multiple monitoring systems, but what sits on top of it is this tool. It's helping us for better availability and performance. Thank you.
Yeah, thank you. Welcome all. We'll start with the usual disclaimer. So imagine the time, which was not so long ago, when every IT landscape were riddled with sleepless nights, relentless monitoring, and a never-ending race to keep our systems up and running. It was an era when every IT landscape or application deployment seemed like a high-stake adventure, and every infrastructure management was a complex puzzle with ever-moving pieces. But then, a revolution quietly began to take shape in the IT landscape. A revolution that opened doors to a world where no ops is no longer a dream, but a reality. Hi, I am Majin George, and along with me, I have Anup Shivaraman. We are from Observability and Automation team at VMware. We leverage and design area solutions to enable our stakeholders achieve better customer experience and productivity. So without further ado, let's get started. Throughout the session, we will see few challenges in the current traditional landscape and how observability and automation or orchestration can help in achieving, overcoming those challenges, the solutions that we use in our environment, a use case, and the key takeaways and benefits from our implementation. If you have any questions, we'll take after the session. So I've just listed few of the challenges that we face in our environment. These are not in the order of significance. So as to start with, resource overhead. Manual tasks requires human resources, which can be expensive and may limit our ability to allocate resources or personnel for more strategic and valuable activities. Next is operational fatigue. I used to face this, not just me, I'm sure most of us in the IT operations world used to face this. Manual operations causes, alert fatigue, and it mostly affects the guys who has to do repetitive and manual tedious tasks. It brings down the morale and productivity of the team. So that's another thing, what we face it as a challenge. Ineffective resource utilization. Manual allocation and management of resources can result in underutilization or overutilization of software and hardware. This can lead to wastage of valuable resources or poor customer experience, right? If it's overutilized, it can result in reduced performance. Next would be the lack of data insights. The traditional monitoring solutions cannot provide in-depth data that is required for decision-making and troubleshooting because we are living in an age of totally distributed microservices architecture. A system again comprises of, if not 100 plus microservices that are talking to each other, right? So these data insights are required to help in troubleshooting in a key way, and it also helps in taking data-driven decisions. Increased risk of errors. Human errors, are very common in manual tasks, and this can cause in misconfiguration, security vulnerabilities, and downtime, right? So this can be costly and damaging, and this can also come as a side effect of the operational fatigue that we discussed earlier.
Exactly.
Now that we have seen few challenges, we'll see how area operations for applications and area automation orchestrator can help in these.
Thank you, Majin. Let's discuss about what is NoOps. NoOps is a concept that aims to completely automate the IT infrastructure when it comes to deploy, monitor, or manage the software operations. NoOps also aims to reduce the operations work, thus by enabling the developers to put more effort on the coding. And here, they don't have to worry about the underlying infrastructure, server provisioning, configuration, management, or even the frequent updates. So this is a significant achievement and towards the innovation. With the right tools and with the help of VMware area solutions, we can achieve NoOps in IT industry. Can we go to next slide, please? Let's discuss about some of the key features of NoOps. Let's start with the full automation. So NoOps relies heavily on the fully automated environment in the IT industry. Without the automation, it is a tedious task for the operations team to perform all the manual day-to-day job, right? Like all the deployment, management, configuration, all these things. So we will see how a fully automated environment, along with the VMware area solutions, we can achieve 100% NoOps in our industry. Moving to the next one is cloud services. Now that most of our applications are hosted in cloud environment, such as public, native, hybrid, multi-cloud environment, it is easy for the developers to write the code in a particular platform and implement it and deploy it. Serverless architecture is a key concept of NoOps. So in serverless architecture, the developers write the code in the form of functions, and in response, it gives as event. Microservices and containers. Adopting to the microservices and containers platform, such as Dockers, made the life easy for the developers because they can deploy the applications in a faster and efficient manner. Now, CI/CD. We all know about CI/CD pipeline. It's a continuous integration and continuous deployment. NoOps relies on the CI/CD pipeline to build, test, automate, and integrate the applications. It also helps to deploy the applications in a faster manner in the production environment. Can you please go to? Yeah. So we discussed about the challenges, the features, and now let's see the kind of solutions that VMware provides over here. So VMware has multi-solutions that can help you in achieve NoOps in your industry. So here, we are specifically talking about two such solutions. The first one is VMware Area Operations for Application, and the second one is VMware Area Automation Orchestrator. With the combination of these two tools and along with the automation, we can achieve the NoOps. We'll discuss more about each of these tools and their features. Let's start first with the VMware Area Operations for Applications. As the name indicates, this is a tool used to monitor your applications and servers' health. It has got a lot of features. Let's talk about some of the key features here. Unified observability. Okay, when observability comes into mind, what are the three pillars of observability? They are metrics, logs, and traces, right? And the tool is capable of capturing all these three aspects of observability. Isn't it great? Yeah. Now, let's move to the next one is the faster issue resolution. So we all need tools which is capable of monitoring your infrastructure, alerting. But it's not just that. We need the tools to help you in root cause analysis, faster issue resolution, and make sure your application has a better uptime. It has got unmatched scalability with millions of points per second. And it helps you, it's a centralized observability platform that lets you operate and secure your Kubernetes infrastructure, which is managed and light on multiple cloud platforms. And last, improved visualization. Yeah. As I mentioned, the tool is capable of capturing all the metrics, logs, and traces from your applications. It is equally important to visualize all this data. So the tool has got a lot of dashboards which shows all these visualization. It has got default dashboards, service dashboard, trace browser, operation dashboards, to name a few. So the default dashboard lets you show all the metrics, logs, and traces from your application. But if you would like to customize and show particular data or metrics from your application, you can choose the custom dashboard, and using the widgets, you can play around and make your own dashboard. The service dashboard lets you show all the service aspects, or I could say the application-related information of your infrastructure. And also, it shows the red metrics as well. So these are all the features that about the VMware Area Operations for Applications. And to discuss more about the VMware Area Automation Orchestrator, our next solution, I will hand it over to Majin.
Yeah, sure. So VMware Area Automation Orchestrator is part of the VMware Area Automation suite. Okay? So Area Automation Orchestrator is a modern workflow management system. We'll see a few of the key features of Area Automation Orchestrator. So one of the key feature is the workflow management system. Area Automation Orchestrator Workflow Designer is an easy-to-use drag-and-drop tool which can help us build simple to complex workflows. And the next one would be the plugin SDK. The plugin SDK helps advanced users to incorporate most of the orchestrator SDK features within their development environment. And the other thing is the wild integration support it provides. It has 100% coverage with vSphere APIs, and it integrates with other solutions using a webhook or incoming webhook, which can be used to trigger remote workflows.
Yeah.
Now the thing is, our workflows are not standard, right? There will be some business use case that we need to fit in. So how do we add those business logic to it? So we can do it using scripting engine, right? So it supports 3 scripting engines, one in Python, PowerShell, and Node.js or JavaScript. So we can use these languages to add your business logic to the workflows. And other the generic operations that happen within a workflow are easy to use, drag and drop wizards. If you have to make a decision, just drop that, decision wizard, and it works on that logic automatically.
Yeah, exactly.
So we'll see a very sample use case because we are just taking it because it's more easy to correlate in a containerized world. So we have a sample application, which is an Nginx cluster, which runs a simple application. And this is the response time and the active connection count, which is pretty flat on a normal day. And you can see that active count is around 15 or 16. But as any customer-facing application, it is bound to increase at certain period of the day, right? Whenever there is some kind of user influx or something. So what happens is, so currently we have only 2 pods running this Nginx cluster, which is happily serving this the environment. And what happens when there is an influx of new connections that happens, right? So we are monitoring it using area operations for application, and at this point of time we see a spike in the active connection count, right? And what we have done is, so these 2 pods are no longer sufficient. It started showing latency in the response time. So we need to scale up, right? So we have a alert configured for the active connections to trigger if it exceeds for 10 minutes a certain threshold. So what it does, it triggers the notification, which is a workflow call for VR orchestrator, right? So this is how this is that designer that I was talking about. It's a very easy to use drag and drop wizard where you can create workflows. So what it does is that webhook call or the notification calls this workflow, which we have a scriptable task which actually increases the deployment state of that Kubernetes cluster, not the cluster, that workload. So that gets triggered. And what we see now is we have increased the scale, the count of the pods to 8. As a result, we see that again, the response time has come down to the normal. And what happens when it continues, like this, it will based on the logic that we have written, it will again reduce the number of pods to keep the resource utilization optimized. This is a very sample use case, just to make it easier to correlate.
Yeah.
We'll come to the benefits part of our implementation.
So with the help of these tools and the automation, these are the key benefits that we achieved in our IT industry. So increased reliability and stability, thus by providing a better customer experience, and increased agility as we are being more proactive rather than being reactive, right? And it's always on the lower cost side. Then all our systems are monitored because we discussed about the capability of VMware IDO operations for applications, which can monitor both the traces, logs, and metrics. So it's all the systems are observable, and it also makes sure that you have reduced risk of errors, as there
Human
are
errors.
much less of manual efforts and work over here. Yeah.
So today we have seen a fascinating intersection of observability and automation. We hope you like this presentation. Please request you to take the survey. And if you have any questions, we'll be here to address.
Yeah.
Thank you.
you.
Thank you for joining, guys. Here is a quick look at the disclaimer. I'll just pause for a couple of seconds. Okay, here is the agenda that we are going to go through today. We'll look at the operational challenges. We'll look at how monitoring enablement process that we have improvised and how it has helped us in VMware IT. We'll look at the central visibility dashboard that we have in place, which is going to help us. And also we'll look at the key takeaways that we have for you guys. Okay, so in this evolving infrastructure, monitoring is of paramount importance, right, for every one of us. Considering the fact or the challenges that are posed by digital transformation, cloud computing, and managing those. In pursuit of keeping up with these things, we have added more layers of complexity. But now, what we need is a tool which can help us in identifying those insights and addressing the challenges. That's what we are looking for. Here is a quick look at some of the challenges. I'm sure most of the IT administrators, IT shops would be going through the same challenges. Keeping up with the updates, manual updates doesn't help us. We need something that we can automate. Operational inefficiency. Every time we keep on updating the agents manually, it doesn't help us. The inefficiency rises. Resource intensive. When we have applications in place which are quite demanding, we don't know when is the next release. We don't know what is coming. So the lifecycle management needs more and more resources, resource intensive. With all this, keeping up with the customization and the integration, that is one of the aspects. Every now and then, there are new technologies coming in. Okay. Every now and then, when the new technology keeps coming in, it becomes very difficult to keep up with the integration. We need more integration in place. Well, here is the architecture that we use in VMware IT. So we have 2-node cluster. We have remote collectors across the region. And we have all these data sources integrated. We have NSX, we have VMware Horizon, we have operating system, service discovery, and the management packs that we use in ARIA operations. So all this is again integrated and used by all the various clouds as well. So coming to the monitoring enablement process, I'm sure each one of you would be going through all this process, right? Let me take you quickly through this process. So first is what we recommend is to look at an application, each application quite different. Don't go by the same grouping methodology that you have been using for all the application. Each application is different. Make sure you have enough scaling models in place. Don't again go by just one scaling model that you have been using for other applications. And also, try to know more about the application, which will help you to use those tags, use those topology views and everything in place, which will help you. And the last one is with regards to the implementation. Ensure that you collaborate with the teams and make sure you understand better and implement it. So if I ask you a question, for all this to be in place, we need at least couple of days of time, right? To go through this and to implement enable monitoring for the request that we have. Isn't it? Yes? Yeah. We in VMware IT are getting this done within few minutes. We have monitoring as a service in place. which takes care of most of the aspects of what I just went through the previous slide. And using that, we are enabling monitoring in a couple of minutes. How does it happen? Well, I have Satya along with me, who is a lead engineer of RA operations. He is going to take us through the process of how we have enabled it and how it is working. Over to you,
Thank
Satya.
you. Thank you, Vamshi. So coming to this monitoring as a service in our IT environment, we used APIs to achieve this service as a monitoring as a service for the end user. It will be very easy to the end user where he can do it on his own instead of depending on the operations. So we have the process like we request an API and we have a framework over here. And we go with these 5 steps. One is the telegraph agent installation and checks, and then resources relationships, and then we will create a monitoring, basic monitoring templates, and then we will map it to the customized groups and policies. Policies is having the custom alert definitions and multiple symptoms mapped with the alert definitions, customized policies, and enabling the alert notifications to the email integrations or a Slack channel or a webhook. And everything will be done, all these processes done by using the ARIA operations APIs. So next slide, so go to. So this is a small demo which we used for the UI framework which we developed. So once the end user get in, and he request for a monitoring request where he can simply provide the details, what he want and how we want to monitor in a simple manner. He can mention the process ports, if any specific URLs, HTTP API checks. Where this, if any agent is not installed, you will get the error over here itself in the same UI. So here this, for example, this VM, which is having all these processes and ports, which is auto-discovered. And you have to select and you have to go to the next slide, where it will configure these process ports by automatically in ARIA operations VROps. So your process ports, everything was configured. You can able to see here. Virtual machine, and here is the process ports, and this is a DL which enable the alert notifications. This is for our EA integration, which is a webhook for a centralized alerts view. And here you can see the monitoring status of those components, process ports and virtual machines. It was deployed over here in VROps, ARIA operations here itself. This is a process which we selected earlier in the configuration panel. And next. Next.
That's it?
Yeah.
Okay. Isn't it amazing to have everything getting it done in a couple of minutes?
The end user itself can do on his own without interacting with the operations team. He can request and he can utilize the same UI and he can do it within few minutes itself.
Yeah. Most of the time what happens is we go back and forth with the application team or the team that is requesting for this monitoring setup. And we are giving the flexibility to them over here to choose what they want, and it gets enabled within a couple of minutes.
And this is a sample APIs which we used in ARIA operations for backend. For the UI which we have a demo, that monitoring as a service for the end user. We use these APIs to backend with a Python and framework.
Yeah.
So these APIs will help for any objects we can create, update, delete, anything we can do. Even power on, power off, enabling a monitoring, or we can disable, we can do a maintenance for the specific objects. Everything we can do via the APIs itself.
Yeah, that's the beauty of these APIs. It gets the job done faster.
Yeah, this is a centralized visibility for applications owners for their test environments, each individual environment or application-wise. We have centralized dashboard where we can see the health of the dashboard and the down below the components, which we mapped by using the custom groups. For example, we have here the platform group where it contains all these VMs, and these are the alerts. You can see the health here itself, which is 75%. Why it was a 75%? Because it has some few alerts, which is infra alerts or process ports, which degrading the health of that application health. Once we fix these alerts, then the health grows up and it will show as 75%. So in this way, we can use these centralized visibility dashboards, and we can easily fix the issues within low time. So it will help the end users to fix their day-to-day alerts issues before getting into incidents. And this is area operations logs for monitoring, where we push all those required logs to login site. This we earlier we called as a login site, now it is area operations logs, where we can push all the logs into this area operations logs, where we can get and filter the logs based on the errors and issues, warning, or status codes of any APIs or application logs or security logs, anything. We'll get it over here in this area operations logs.
Yeah. Well, most of you might have a question. Why do I need to use area operations when I have area operations for logs, which does the similar kind of monitoring, helps me in finding out those anomalies?
Why? Because this area operation logs, we can integrate with area operations. Once we integrate, we can get the application logs in area operation itself. Before we are getting to the incident, if you, for example, if your service went down, sometimes your service you cannot identify whether it is a down or it's a kind of hung or whatever it is. But at the same time, if you go with your specific time period, what happened to my service in area operations, there it will give you the logs along with the details within certain period of time. So we can get it everything in logs along with the services, infra, everything in area operations. So that's the reason we have this slide.
Okay, what Satya is trying to say is the beauty of both the tools, you can have it in one place so that you can better troubleshoot. That's great.
And this is our area operations network insights for monitoring, where it will monitor all our networks, switches, routers, everything. And this is also, it will provide you the network insights and network monitoring related alerts. And this network insights also we can integrate with area operations. We can get your application insight related to the network incidents. So if your application went down, if it is a non-responsive, all your services are up and running and logs looks fine, but you don't know where it was the issue. But if once you integrate these area operation networks into the area operations, there you can able to see all these network related information and issues, alerts, if any latencies, packet loss, everything you can able to see in the area operations main centralized visual dashboard itself. So in that way, the area operation networks, it will help you more in when you integrate with the area operations.
All right. So we have all the integration in place, everything is now set, but it boils down to that one critical scenario or the incident that happens. How do you troubleshoot that? How do you identify the metrics which you need to have so that you can troubleshoot? So we have troubleshooting workbench. This is one of the great features that we have in area operations. Using this, you can level up and level down based on either you want to look at the container, or you want to look at the VMs, or you want to look at the checks. Based on that, we have different capabilities using all the management packs. Even though it is a process, it is a database, all the events will come into this place. So this is one of the great features we have in the tool, which we can leverage and make use of. Okay, so I have a question for Satya.
Yeah.
So everything is in place, but where do we start? Most of the people don't know where do we start and how do we enable everything that we showcased.
Yeah, coming to that, First of all, when you have your array operations in place and ready, then you have to start integrating with all your sources, like vCenter, any public clouds or private clouds, AWS, and some of the components like vSAN or any management packs like Oracle databases, WebLayer, Nginx, JBoss, anything you can integrate and enable the plugins to get the metrics into the array operations first. If once you've done that as a day one operations, then we can go back to the day two operations here. So when it comes to day two operations, first of all, start with symptom. What is a symptom? Symptom is nothing but where you have a potential cause of issues with respect to any thresholds or any latencies with respect to the metrics. You have to configure the symptom the first. Symptoms may have either a single symptom or multiple symptoms. You can map it with alert definition. And here you have wait cycles for any alert which comes to here. If any anomalies which is detected, you no need to go for immediate alert. You can take some time. Maybe next it might be an intermittent alert, so maybe it will go in a next cycle. So wait for 2-3 cycles. If it is still going on more than 3 cycles or 4 cycles, you can enable the alert in alert definition. And this alert definition will be mapped to the specific policy. Why we need the policy over here? Policy is required here for a customized thresholds for a certain devices. For example, I have an application, Oracle application. Oracle is a databases in our environment, which is the most critical one. I don't want to go with any, for example, I'll take a file system. So file systems, they need it as a 50% of threshold, they need an alert. But normal other applications, which is around 70 or 80% of thresholds. So I do have to segregate, and I have to specifically, Oracle, I have to keep for 50% of threshold. For that, I have to map a policy, and once I map the policy, I'll go and add the Oracle systems into the custom group. So the custom group contains all the Oracle virtual machines or the objects. So the objects, everything mapped with that policy, and those objects will apply for all the thresholds, which for a 50% of threshold. So that's why we have the policies here. We have to create a multiple number of policies based on your requirements, and then proceed for the next. So next is the container tags. We have a multiple tags over here. Like tags is nothing but just giving just a name to identify as an application name or a team name or end user name, which will help you for identify in the centralized dashboard. The centralized dashboard also we have some kind of tags. You can put that test environment Oracle, or I can keep it as a Oracle as a tag. So by selecting the tag, I can visualize all the Oracle objects over there itself. If you have any health degradation, everything I can able to view there itself. So tags also, if you want to use it for a better and centralized visibility. Yeah, coming to the next is the notifications. Sending the notifications, we have mail notifications, Slack and webhook. And by using the notifications, we can integrate with any customized tools. Like we have an event aggregator, which is a centralized monitoring alerts, which is for a command control center. They use the dashboard and they take any action if any incidents occurs. So that way we can create and enable the webhooks for all the alerts.
I'm sure most of you might make use of this workflow which is out here. Okay, so before I just touch upon the key takeaways, how many of you would be interested to have such an automation in place like monitoring as a service? That's great. So here are the key takeaways. So get all the source insight into the tool that helps, like say for example, array operations for logs, if you are using, or the networks and other tools. You make use of the robust APIs we have for array operations. That really helps. And again, the end-to-end troubleshooting dashboard that we showcased across, the troubleshooting workbench, that really helps to address the incidents. With that, I would like to end the session with this note. Please do provide us the feedback, and this is how you can get in touch with us. We are from VMware IT, where we have implemented all these best practices and we are making use of it. Ladies and gentlemen, this is RE Operations. Thank you.
Thank you.
Cool. Hi, everyone. Thank you. How's everyone doing on the Thursday? Who's catching a plane later? All right, who's catching a plane tomorrow? Cool, okay. So, are you going to go party the last evening? Okay, good. Welcome to my session. So, I just finished my slides. Let's see. Next. Oh, cool. Yeah, so I'm Robert. I work for ITQ. We're a consultancy in the Benelux, well, actually in EMEA. And we do a lot of across-the-board VMware stuff, infrastructure, but increasingly cloud-native. We have about 22 cloud-native people, and I'm one of the practice leads for that group. So I work with a lot of customers, doing a lot of Tanzu-ish stuff, a lot of TKG. We're also part of the Vanguards. Yeah. Okay. And which is kind of like a focus group of customers and partners for VMware. If you're doing anything with Tanzu, have a look at the Vanguards. It's really cool. You'll get a lot out of it. A lot of like behind-the-scenes stuff as well, and roadmap stuff. You know, you have to sign a bunch of NDAs, but you know. Okay, so yeah, I don't really have slides. I'm just going to show you the template I was given. No, actually, I do have some slides. Apparently, Hock said AI is easy peasy. But don't worry, I'm not going to do a talk about AI because that's been done to death this week. But I did use AI because I needed some slides. So I asked it to create my slides. It's OK, I guess, kind of. You can do graphics. And you had to import the code before. Now it can just generate the image because it's multimodal, you know. Anyway, so I made a nicer one. This session is about Kubernetes resiliency, but there's too much to cover in 20 minutes, 18 minutes. It's a huge, huge topic. There's so many aspects to this. I'm just going to cover like some real basic stuff, but it's this most important stuff. So in the infra world, we're kind of used to these two, right? We'll have. Sometimes we won't have any resiliency or high availability at all. It'll just be one thing, in a VM, and then we trust vSphere HA, which is probably good enough, right? But sometimes, you have Postgres or Microsoft SQL. We've had Windows clustering for way longer than vSphere even, right? But it'd usually be something like this: active-passive replication, and then if you get into the realm of things like stretched cluster with vSAN, that's actually an active-active system. You can read and write on both sides. That's really cool, really handy, super resilient. But then it gets a bit more complicated because what if this thing breaks? All right, the link between the two sides. So now we need a witness to be a tie break in case this breaks, right? So this is the resiliency models we're used to in the infrastructure kind of on-prem enterprise world. But when you talk about cloud native, you're talking about microservices architectures, and you're talking about distributed systems. And distributed systems work kind of like this, as in multinodal, n+1, stretch horizontally, and everything replicates to everything else all the time. And it's also active, 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 active. And you trust these systems to deal with state in their own way, in a consistent way, so that you don't need to worry about it. So the new generation of database models are all like this. And Kubernetes itself uses something like this. It uses etcd, which is a distributed database model that works like this. But notice how I've drawn 3 boxes. Because remember, for active-active, we needed a witness. Well, if I can also just replicate the data across 3 nodes, and then I have quorum as well. So if there's a split anywhere, like here, this will solve that as well, because basically each of the nodes acts as a replica in these kind of systems as well, right? So this is a really cool way. I can write and read and write everywhere. The data's available everywhere. It's being replicated everywhere. It's available everywhere. And it's resilient against interlink failures. between the components. Yeah? This is a very cloud-native way of doing state and doing data. So in the cloud-native world, this is what everyone is used to doing. If you've built a cloud-native application architecture in public cloud, you have AWS, Azure, whatever, gives you availability zones to use. And you say, OK, I'm going to put part of my app in this one, and this one, and this one. And the application, or the data service backing the application, should look like this. So you get that. Right? And the application is responsible for dealing with its data concerns. In the enterprise, however, this is our reality, right? 2 data centers, and data concerns are not left to the app. They're left to infra to solve, using Metro cluster, stretched cluster. If it's a database team, we rely on them to do replicated Postgres, replicated Microsoft SQL or MySQL, clustered. I say replicating. I'll usually talk about the cloud native when I say replication, right? But it's all the same thing. This is like fitting a square peg in a round hole, or the other way around. These models are not compatible with each other, actually. Because if I have a 3-way thing, how do I put 3-way into 2-way? Do I put these 2 in there? Or do I put that one in there? OK, I guess that would work, but what if this fails? If there's one over here and this fails, then this dies because it has no quorum, and this one will survive. But then I'm like, OK, so I always kind of know which site will survive, so I always have a leading site. But we know this. We know this from vSAN as well. We know that from Stretch Cluster. There's always a site that wins. If all things being equal, there's a site that wins. Same here. But what if this site, if I have 2 of these sitting here, what if this site dies? I lose the service here because the site died, but I lose this one as well because whatever's left here doesn't have quorum. It dies as well. So this is a problem, right? This is why you can't stretch Kubernetes across this. The moment you try this, you create an unstable situation. And that's the reason vSphere with Tanzu does not support being deployed on a stretch. They won't support it, and this is the reason why, right? So there's a problem. How do we deal with this? Because if the enterprise comes to us, the business comes to us as infra people and says, we're used to you taking care of availability concerns. Solve this for us. How are we going to solve this? Now, the answer right today is kind of simple. Oh, by the way, yeah, more AI fun. That's what I came up with. It's pretty cool. I don't really know what's going on, but it's kind of epic. So right now, the validated design, the design you go for is basically this. I do a K8s cluster on one side. I do a whole nother K8s cluster on the other side, right? And I don't stretch. I don't do data center stretching. I don't do vSphere stretch. These are 2 separate clusters, right? By the way, I didn't have time to put the graphic in there, but if you go to the vSphere 8 vSphere with Tanzu documentation, there's now 2 deployment models, right? One is single cluster, single site, single availability zone, in other words. And the other one is basically this, right? 1, 2, 3. They do a 3-zone architecture. Now, the funny thing is, if you read through those docs, you're basically like, does this mean I need 3 data centers? Yeah, kind of. Like public cloud. Who has the money to do this? Who's going to buy a 3rd data center? Right? Not many of us. But it's a conversation I'm having with some customers. They say, if you want to do this properly, you actually need 3 data centers now. And they call me crazy, and I don't blame them. OK, so this is the way we go for now. Cluster on the left, cluster on the right. But that doesn't actually solve our problems, because we can now run stuff inside the cluster, but you have all these different kinds of data types, and guess what? We're back to the same problem again, because, if I have a Postgres database, I can have a passive replica on the other side. Which site lives and which site dies? What happens when the inter-site link goes down? What happens when that site fails? Does that fail over to the other side? No, because we're not stretching, so we don't have vMotion. So how do I get Postgres to automatically come up here? Right? Now, Minio is slightly more cloud native, so you can do some more interesting things with that. But remember, I still have to divide things over 2 sites. The model doesn't fit, in other words. How do we do these things? So, I don't have an answer for you. Presentation over, right? I actually don't, because the industry doesn't. Everyone's struggling with this right now. As more workloads, cloud-native workloads start to be developed inside enterprises, and the enterprise topology is 2 data centers, no one knows how to solve this. Everyone in the cloud-native community are like, well, do it in public cloud. 3 zones, what's the problem? The problem is this. We're going to have to deal with this somehow. We'll do questions after. So there's another part of this puzzle that we're going to have to deal with. Because if it's the workload, if it's the app, especially if it's cloud native, I can leave app and state and data concerns probably maybe to the application team, to the application owner, to the developer, whoever came with the application, right? But many of these workloads, they simply assume they exist inside one Kubernetes cluster. And they say, look, we need data, we're going to make some volumes, persistent volumes, right? Kubernetes. So you get persistent volumes. How am I going to get the data over there? Now, I'll tell you, public cloud doesn't do this for you, right? I mean, there are some extra services probably in Amazon, I haven't looked recently, that allow you to do data replication. There's nothing in the vSphere portfolio, the VMware portfolio right now, that can do this if there's not a stretch already underneath. And remember, stretch is not supported. How do we solve this? We can't. There's no answer. Right? Now, there are third-party solutions that might be able to help. I might not want to mention them here. But this is a real problem we have to solve. If an application owner says, we're going to build me a cluster, produce me a cluster, and I'm going to put a workload in there, you have to ask them this very simple question. Are you going to back up your own data? Are you responsible for backing up the persistent volume objects inside the cluster? And if they say, no, Infra takes care of that stuff, right? That's a conversation you need to have with your application owner, with the vendor, with the developer, whoever's coming to you and saying, we need Kubernetes, we need TKGS clusters. Now, if you're lucky, you can keep the data outside the cluster, right? If you have an established DBA team or whatever it is, you can outsource it to them. And then some of that problem goes away. But most Kubernetes applications, it's hard to pull out the database. Sometimes you can't do it architecturally. Sometimes the Helm chart gives you an option, right? But what if the only one they support is, I don't know, MongoDB, and your DBAs only do Postgres or Microsoft, right? So what are you going to do then? Right, just stick it in there, but then how do you get it there? So part of this solution might just be to redeploy stuff, but then, and then restore from backup. But then how do you get the backup over there? Do you guys know how to do backups in Kubernetes? Right, Valero? So the nicest thing about TMC is it gives me a nice UI front end for Valero. That's my main use case for TMC. If you can run TMC. But in other words, you're going to probably have to do that backup for them. And if something goes down, you're going to have to import it, restore it here. You probably want to script that, right? Because you're going to have hundreds of these, and you're going to have terabytes of data in these. But the point is, you might have to deal with it. Actually, I'm going to guarantee you're going to have to deal with it, because not all apps are going to take care of it for you. Is there some water somewhere? I forgot to bring some water. I'm like, These are important too. None of this works in isolation. We all have dependencies. Now, you know the usual dependencies, right? DNS, Active Directory, NTP, stuff like that. But the way most advanced users will... Oh, thank you so much, sir. The way most mature application teams will put stuff into Kubernetes is usually in a GitOps kind of way, using Argo CD or using the stuff Tecton built into TMC to do GitOps. the registry, right? Harbor. You're going to run Harbor inside. Harbor has a PV. You need to back that up. Harbor doesn't do it for you. It's probably the first thing you're going to have to back up is the Harbor image registry persistent volume, right? Or you have to replicate it, but you know, the failover is not automatic. Oh, another one. Great. Thanks. Awesome. I can choose. This one's better. You could run these outside of Kubernetes. It might be a good idea in some of these cases. There's a bit of a chicken-egg problem going on here, right? Because some of these dependencies sometimes run inside the cluster itself, or a separate cluster, but it's, you can't stretch any of them. So remember that when we're used to thinking about management dependencies, so they're vCenter, NSXT controllers, we tend to stick them in a stretched management cluster, right? But Harbor is a cloud-native app. You can put it in a VM. It might be maybe worth thinking about. Git is GitLab runners. They're running Kubernetes. They're not running on a VM. So if part of solving this is going to your developers and saying, just redeploy on this side, well, yeah, but how about these? Maybe these aren't your concern. Make it someone else's problem. But they might assume it is your concern, right? Because, like I keep saying, infra solves it, right? This is basically just what I want to tell you. There's really nothing more than this. Be aware that this is an unsolved problem space in the community. Be aware that vendors are working on this to fill in some of these gaps. So is VMware. But we're not there yet. And you have to deal with this today because you start your cluster and immediately you're going to hit some of this. Takeaways, figure it out. And if you can't figure it out, that's what partners are for, right? And this one is probably the most important one. Don't assume anything. Don't assume that they will take care of their data concerns. Don't assume they will back up and restore their stuff. Do not assume they have an availability model. And they should not assume that the cluster is stretched or somehow magically will reappear on the other side, because it won't. They might assume that if they're used to cloud native in public cloud. So conversations. And this is the hardest one, seriously, because not all of us are used to talking with developers. And developers are certainly not used to or trust infra. But we're going to have to, because the only way to make this stuff successful is those two communities need to come together real fast to solve this kind of stuff. That was basically it. So, questions? How long do I have, actually? Off stage? OK. Shall I just stop it? Cool. Thank you very much.
So welcome everybody to our session. We want to talk about a simple application and what it means if this application becomes enterprise grade. My name is Jürgen Sussner. I'm from Dativ, Germany, a company for tax consultants, auditors, lawyers, and that is not that boring as it sounds actually. So we do a lot with platform and platform engineering. But imagine we have an application. We have a groundbreaking idea for that application, and what if that application suddenly gets really successful? So let's have the idea, I don't know, like the war of IntelliJ or Eclipse, I don't care, I like both. But let's take an IDE, create that application, pick a source code repo, start coding, and you have your application, and you're pretty much done. You have an application, put it on a server with a database, it's usable to anyone else, we're done. Well, at least this is where my hobby projects end at that time. But what happens? The application isn't available because the server itself, the single instance server, is in maintenance. So, okay, I heard about that thing called Kubernetes. It offers high availability. Put that application on a Kubernetes cluster. Okay, I have a high available cluster, 3 master, 3 worker nodes, database here, application there. We have a high available application, but it requires re-architecting the application, packaging in a container, and it requires the knowledge how to configure such a Kubernetes cluster. Okay, next problem. My application is really responding slow. And that might be a problem because the database and the application sharing are the same CPUs. So let's use another Kubernetes cluster for the database itself. I can tune them to more specific hardware requirements of a database, and I tune them to more specific hardware requirements of the application itself. But that requires high available databases. And I have to have the knowledge how to manage a high available database. I have 3 availability zones, I have replication concepts, and I have to know about all that to be able to run such a high available database. So, a friend of mine said this, it's 9 p.m., do you know what your clusters actually are doing? No, I don't. I don't know what my Kubernetes clusters are doing at the moment, and I have to add monitoring. For the sake of this demo, let's say, okay, we had another cluster that has all the monitoring logic on it. Can be Prometheus, can be Grafana, can be whatever monitoring system you can imagine. But it requires to know how to operate this in a high available fashion. This should not be bundled with this because this can fall apart. I still want to have the monitoring information. And I also have to have the knowledge about dashboard design and all the stuff that's written down here, how to act in an emergency. So I have a pretty complex setup, but guess what? How did we deploy to that? I can start deploying using kubectl on my private machine, but that's not how I want to deploy software. I usually use pipelines. So, okay, I have pipelines. Well, it requires good unit tests. It requires understanding of pipeline technologies using Jenkins, Tekton, GitOps flows, whatever. But it requires the knowledge of all these methodologies. And it also requires some sort of CV management, for example. I have to check if my application is still secure. As I said, unit test, integration. I have to care about rolling deployments. How do I do rolling deployments? How do I avoid downtimes at all? And it requires specific tool know-how. So a lot of requirements with that. And one point I want to point out is the license management. Especially for enterprises like us, we can't use every open source license because it sometimes would require us to open source our software itself. So we have specific requirements using only specific open source licenses in that process. And again, how do we manage all the clusters? The clusters should be aligned to certain policies. So I would need a cluster management solution as well. I can build that up on my own using Flux, for example, or Argo. Or I can just buy one for the sake of its demo. Let's see, I build it on my own. But it requires a definition what is common to all my clusters. And so there are a lot of more things you can add, maybe identity gateways, maybe IDS or IPS systems, just to protect your assets even more. And there is much more to come on this. If you think of compliance policies, like being a C5 certified, like going multi-cloud, like having global load balancing, like having this environment not just once, but once per stage, a dev, a QA, prod stage. And you will end up in a quite complex setup. So the issue is what I really wanted to do was creating that simple application. And where I ended up was all that stuff. 5 Kubernetes clusters. I know knowledge about monitoring metrics, cluster maintaining, pipelining, identity gateways, and no idea about compliance or certifications, for example. This is where I ended up. And that is where everyone will end up when trying to create enterprise-grade applications. So there's a research from MongoDB and Stack Overflow that says you spend up about 40% of your time in developing your application, so 2 days a week of development, and the rest of the week is meetings or management of infrastructure. And how will this scale to, let's say, 100 teams, 500 teams? This is simply not possible for larger enterprises. And if you look at the Cloud Native Computing Foundation, Kelsey Hightower says, just build a platform. It's never been easier before. Just look here, pick 200 tools, and you're done. Maybe it's probably not that way, but let's hand over to Marcus. He will show you what can be done.
Thank you, Jürgen. Hi, my name is Marcus, so I'm the pre-sales architect for Datev, responsible. So in many decisions and discussions with Jürgen, we decided what we have in our portfolio. So when we're talking about products, not a platform itself, so we're talking about each of this kind like Lego bricks. So you have Tanzu Application Platform, you have Tanzu Application Service, Tanzu Kubernetes Grid, Application Catalog, Tanzu Mission Control, ARIA Operations for applications, and how they stick together so that we build a consistent platform for all the requirements that we need. So and that's look so that we going to like the Kubernetes infrastructure. So we built this on top of our different like Cloud Foundation, VMC on AWS, and vSphere, for example. And on top of that, we have our supervisor cluster, and over that, so all the namespaces we need and provision all the kind of infrastructure and the storage behind that. So and then we go further to have the application catalog. So that's a solution that we have upstream open source components in there that the developers could use and on multiple platforms. And choice of infrastructure, so that's really easy to use that. And then we go further to the Tanzu Application Service. So we integrate this in the development space so that the developers could easily consume the platform. So the complete infrastructure could use the build packs, for example, in that kind of ways. And the infrastructure is complete agnostic down there. Yeah. So, and that's the point, how we manage Kubernetes clusters itself with Tanzu Mission Control on it. So that's the reason why we could use different Kubernetes infrastructures. With Tanzu Mission Control, we have the policy management, we have the cluster lifecycle management, the application catalog, and we could use it on all the different infrastructures like VMC, edge computing, for example. So, and that's really the single pane of glass on top of that to manage the different kind of Kubernetes clusters. And then comes the point how we monitor this, how we find issues, errors, and so on. So that's really, with ARIA Operations, we have a solution that we could use beside on the infrastructure. Then on top of the management layer of the infrastructure, like VROPS, for example, and we realize automation. And after that, we could integrate this in our, I would say, in the developer platform, for example, to integrate this in the different kind of containers of the pods and in the applications. And it's really easy to show the development team how they want to use the different kind of ways. So which metrics. So when the database is going slow, so we have different kind of response times, for example. And what are the metrics? So when you define it, so and the possibilities here. So we use here Tanzu observability and get all the kind of metrics and all the kind of information in that application and front end. So that's really easy to analyze what's going down, what's going up, I have longer response time. I need some more Kubernetes clusters, for example. So that's really easy. So, and then we're going on the Tanzu application platform. So that's the layer or the point that the developer comes from here, from this kind of ways, and says, okay, I have a portal and I can use all the kind of service, and I don't care about the infrastructure down there. So that's the other layer behind there. So that's the infrastructure layer, and that's I would say operational layer for the developers, for example. And then we go on the different kind of services they consume. The applications could use the build services, the pipelines, the workflows on that, the APIs, for example, and that's all running on the same consistent infrastructure. So, and that's we coming to the point and say, okay, so we don't picking any kind of this different Gits or some solutions from the cloud native front end. Yeah, so then we go to and say, we're talking about a platform for application engineering. So that's the point. So when we're talking to each other, so Jürgen and I, so we decided, so that's platform engineering, for example. So when we look at, I would say, in our marketing at VMware, so everybody talking about platform engineering, for example. So they're talking about, we have vSphere, we have VCF, for example. Then we have some observability solutions. We have TAS, TMC. And when we stick this together, so we're building the consistent infrastructure complete on the same technology, like in the public cloud, VCF on the edge. And then we have the Tanzu Mission Control for managing the Kubernetes infrastructure. On top of this layer, we have some security stuff like NSX, for example. And then we have the layer for the developers or the services for the developers like TAS, the build and the CI/CD services, the application catalog, the Git repository, all on that. And the front end for the developer is the portal that they get and can consume the services, and they then don't care about any different applications and solution on top of that. Yeah?
So basically, you use all the different VMware products, which are building blocks, and you stick them together to a platform that suits your needs. You may not use all of them. Maybe you just use Tab, you just use TAS. Maybe you don't need the app catalog, but at a sum, they will form something that is greater than the individual products itself. It's the platform you can offer to your development teams that will help them create their applications to the customer.
Yeah.
Okay?
Yeah.
And with that, you will reach maybe not the 90% productivity, but you will be able to reach a productivity, let's say you can spend 80% of your time, 4 days a week, just coding your application. The rest is done by the platform, the automation and the tools in the platform, and your developers can focus on creating what delivers really value. That requires more than just tooling. It also requires a good documentation and self-services, and usually doesn't end at the boundaries of the platform you can build with this Lego building blocks. It also requires a bit tackling all the infrastructure around your platform, like existing processes, ITIL processes, and what else belongs to that. But you will be able to reach that. Obviously, you cannot avoid meetings. You will have to have some meetings at all. You will have to talk to some colleagues as well, and you will have to manage some set of infrastructure. But it's a reduced set of infrastructure. So the essence is treat your platform as a product and build it for your developers' needs. And with that, I want to have you some takeaways. Visualize what you want to achieve. Find common bottlenecks and create self-services around. Find these friction points where your developers struggle. Look what a tool maybe can help you at this. And find the right developers. Find the right tool to make developers work easier. Remove paper forms. Paper forms are always a hassle because when I'm a developer, I wanted to have that service and I want to have it now. Even if it's just the 90% solution, 90% solution that I can get now is much better than a 100% solution that I have to order for 2 weeks. Platform as a product. I always tell this, and when you think of your platform as a product, you have to talk to your customers, to your developers, to understand their needs and to understand what you can do better to help them fulfilling their job. If you treat your platform not as a product, you don't treat your developers as your customers, you treat them as your users. Users have no choice, they have to use, and you don't have a motivation to make your platform good. So that's why I always talk to my developers as my platform customers. And talk to them. Talk to them really often to understand what are their needs. Maybe try to understand this developer piece of mindset, which is somehow not common to the infrastructure guy mindset. And I've been on both sides of the wall, you know. So even in large enterprises with a lot of regulations, you can work as efficient as a startup. You just have to create the platform, and the just might be a bit bigger. And with that, I want to thank you. Please take the survey. And if you have any questions, feel free to ask.
Yeah.
Okay, cool. Hello, everybody. Good afternoon. Thanks for joining me here in my session, talking about Tensor Application for Dummies. I actually, in the very first stage, the presentation was called Application for Managers, and in brackets Dummies, but I figured out it would be so harsh, so I stayed with just Dummies. My name is Christoph Filno. I'm working with Unique Projects as a technical lead, and been into the Tanzu portfolio for around four years. And I want to explain in a very, very high-level overview what the Tensor Application Platform is all about. Because in the last couple of months or years, a lot of customers and colleagues came over and really asked, well, the marketing department did a good job on explaining why we need it or why it's the next big thing, but what's really behind this name? So I just want to get briefly into one of the few slides I got from the VMware colleagues that you get an overview about where you need to put the Tensor Application Platform at all. So what's really the benefit from it? And as I said, it's just one part of the portfolio at all. So we got like 3 different bigger topics, the TKO on the right side, we got the Tensor Labs on the bottom and the TAP on the left side. But then again, you see the slide, you don't really know what's behind the curtain, what's really behind the software product. And VMware came back with another slide, with another design. And said, okay, let's look a bit deeper at least. And one more thing you get from this slide is, okay, it seems to be that there are like multiple steps, multiple packages, something like this, what's really into this Tensor Application Platform. And then we are wondering why did they color it in different places? So they started to talk about inner and outer loop. And then again, customer and friends came over and say, what's this? What's an outer loop at all? So VMware came back and said, okay, we got another slide. Maybe you can work with this as, even better. So it's about developer productivity. It's to make your developer being able to get their apps into production on a more easy way. So maybe you can work with this. And it's all about this path, the steps you need to produce and walk through to get your application into production in a very fast-paced way. So, well, I showed this to colleagues and customers, and they were like, okay, doesn't explain even better what's this. So I get back to the VMware colleagues, and they showed me this slide. And this slide is actually a bit more into the Tensor Application Platform. And then again, it shows as well what the Tensor portfolio is all about. So we got even more different topics on the right side, which I'm not explaining at all. But if you look at the bigger picture over here, that's actually something you can start to work with, because that's explaining, in a really high-level overview, what TAP is all about, what you need to expect when you're trying to implement or even think about this. So, well, I showed the customers this, and they were like, okay, but what's these words all about? So explain me, please, in a really childish way, what I need to expect. What are these different topics? So I tried to step in and explain that when you try to implement TAP in your infrastructure, there is different steps you need to consider. So in the first place, it's not just one product. It's not just one simple installation which you can put on some service or having a service running somewhere. It's different packages combined to make your developer able to produce the application and bring it on its way to the production. So then again, we found a picture which shows you that there are different steps you need to walk through, or at least the application, to get from the start, from the coding, from the initial thought up until its production. So I want to look deeper in these steps because Tensor Application Platform is not coming in just one flavor. It comes with more different kind of installations. So which kind of installation? We got like, oh, second, I was too fast talking. So we got different installation methods. There is a full installation, of course, so you got every package you want. There is like a view kind of installation where you just need to implement a specific kind of or a specific number of steps to just look into your infrastructure, look into your path to production. Some kind of build installation just for the developers. But what's really in these kind of installation? Well, that's where it gets tricky, because if we put all these steps into the installation, into the packages, we have a bit more to consider. And I'm not kidding. It's a little bit more. So let's take just a short look at the list of applications which I needed to redo this morning because they keep updating it on a very fast-paced manner. So, yeah, that's actually everything you can have into the Tensor Application Platform. And that's where it gets interesting, because you need to think about all these packages, all these kind of steps on your way from the installation or from the initial thought from the developer up until you get the application into production. So I won't go into any details. You can have a look at it on the documentation at VMware. Talking about everything, we would still stay here up until this evening, I think. So I would rather go into a detail why we need to have all these packages installed at all. So we have, as I said, different kind of installations, but in the first place, I want to focus on the full installation, because that's where we, in the best way, want to go. So why do we need it? As I said, we have different kind of developers. We have, at best, multiple developers who all want to have their application as fast as possible into production. And that's where the different steps came in, because on the infrastructure point of view, you want to have a secure way, a standard way, a predefined way, which the code needs to go through to be in production environment. And in best case, this way, the standardized way, is the same for every application the developer is building up. So what we need to focus on is like not what the developers are thinking or what they actually are programming at all. We need to focus on what the code is running through. So when I showed these slides to the customer, he kind of made the face like this. Okay, you talked about it for a couple of minutes about everything what's on Tensor Application Platform at all, but am I dumb? I really didn't get it. It's hard to explain, hard to figure it out. So I tried to go a step back and was like, okay, then what about all the buzzwords? What about the buzzwords we saw on the slides? What about the buzzwords we heard from the marketing and sales guys? So Tensor Application Platform is just a bunch of packages you can install or provide in different ways to get different kind of installation. It's not the whole portfolio, it's just a part from the Tensor portfolio. There's even more. There's TMC, there's TKGI, there's TAS, there's like so much more to know. as we saw, we got an inner loop, an outer loop. The inner loop is, on a very basic way, the part the developer is using to produce its code until it commits to the infrastructure to make it somewhere running into the infrastructure. The outer loop, on the other side, is what the VI admins and the security department is actually looking to make it even safer and standardized to get the code up and running in the production as well. We saw the buzzword supply chain. What is supply chain at all? Well, it's a predefined way or predefined steps at on a very high level where the code needs to go through until it's in production. That's actually a supply chain, if you think about it on a very basic way. And CI/CD. CI/CD is an automated process of testing and deploying the applications into production. And then again, it's just an automated way. So I figured out at the end that the easiest way to show my colleagues and the customer is to show them the GUI, the tab GUI, because it has a GUI, at least for the VI admins. And does anybody know how it looks like here in the audience? No? Nobody? Awesome. Okay, then let's have a look. In the end, it's just a GUI. It's really focusing on the standard VMware console kind of way, and it's really nothing more. And it's really simple to wrong picture. It's really simple to understand because there is nothing complex about it. So we got, in the end, for the VI admins, like a basic overview about what is running, where are our supply chain, how is it called, where is it installed to, and really everything on a dashboard kind of way. But let's have a look into the navigation on the left side. So we have our home. It's like a dashboard about what you've installed previously. You also have the opportunity to implement documentation about what you really build up in this infrastructure. You can have application accelerators, which will help you start deploying your code, start implementing your code, to start to make it like your first steps for the developer to get your code up and running. You of course have the option to look into APIs as well. And the next part is probably the most interesting because it shows you what supply chains, what standardized ways you already predefined to get your application into production. And when we look deeper into the supply chain, we can also see the different packages, the different steps the code must go through to make it into the production as well. And it's not just that we can see what the steps are, we got information out of it. So we can see if the application was successfully running a package, like a security scanner, and give you information about what's happening inside it. So the steps you can see here are not written in stone. You can modify them. You can even put more into it. You can scrap some steps out of it. It's not hard coded for the VI admin, and that's the beauty of it. So you can really figure out your own way, but your own standardized way to make your developer able to commit their code and paste it into production. Maybe you already saw it, but the screenshot I show you here are from the hands-on labs from VMware. I really can recommend these hands-on labs because it gives you a cool insight about what Tensor Application Platform is all about. And that's actually the end of my session, I really want to recommend again that the Tanzu hands-on labs is the next place to be, I think. But if you also want to have a look into the documentation, I just paste some links here as well. And that's actually it. I appreciate your time over here. Thanks.
Hi guys, my name is Paul Murphy, and today I'm going to discuss running your LLM fine-tuning operations on a centrally controlled system. Today I'm going to run through fine-tuning an LLM, the problems that we see when we're running it, and how the centrally controlled system will help. So you're probably wondering what a centrally controlled system is, and I will get into that shortly. But before I get into that, I first want to discuss the current state of LLM training in 2023. So we can't discuss LLM training in 2023 without first discussing Hugging Face. Hugging Face has been a game changer in the industry. It massively simplifies serving your models. It makes versioning your models and your data sets so easy because it's state of the art. And also, using its SDK, it's become much simpler to train or fine-tune models. So that's what we're going to do today. We're going to use the Hugging Face SDK to create a model, and we're going to see what problems we see, and then we're going to see how the centrally controlled system can help address those. So today we're going to build a sentiment analyzer for reviews. And so what a sentiment analyzer for reviews does is it looks at a text review and it figures out what numeric score that the writer of that review would have given the product. So for example, if the review was "this food is awful," presumably that would have been a 1-star review. Whereas if someone wrote "location is fab" and staff were amazing, it's a 5-star review. Now it's easy to see why this is useful because it's often good to be able to take text reviews of products and give them more numerical values that we can analyze later. Okay, so we're going to use the Hugging Face SDK. What the hell? So the first thing you need to do if you're fine-tuning a model is you need to load your data set. And as I was saying, Hugging Face has over 70,000 data sets, and it makes it incredibly easy to load a data set. All we need to do is give the name of the data set we want. And in this case, there's already a perfect data set, which is called the Yelp data set. It is text reviews of the places and the products, and then the label is a number of stars from 1 to 5. So first of all, we load the data set. Next, we want to use a base LLM model. So in this case, we're using the BERT model, and we say, use the BERT from pre-trained, and we want to do sequence classification. So what sequence classification means is that we classify a sequence of text into a number of buckets, 1 to 5, 1 to 5 for 1 to 5 stars. Okay, so now we have our data set and we have our model. We want to start the training. All we need to do now is just pass in a few arguments. Like, first of all, we need to say, well, once the training is finished, where will we save the model? Where do we save the checkpointing files? And what reporting platforms do we report into? So here you can see that we're reporting into weights and biases. Then we just pass all that into our trainer and hit train. Now, that's basically the amount of code you would need to build a sentiment review analyzer. And so you're pretty happy, you've written your code, but now you're wondering, well, where do I run it? And so, the most simple approach for running it is, if you have a GPU on your own computer, run it on your own computer. And if you don't have a GPU on your own computer, well then provision a GPU in the cloud, and then clone the code onto that and run it there. And that is how a lot of people get started. But in a large organization, there are a large number of downsides to this. Obviously, once the model is created, there will be a lack of traceability into which version of the code created that model, which data set was used to create that model, even how much epochs was used to create that model for trying to reproduce later. Also, especially if you go with the provisioning the GPU, it's a very manual process and it's extremely ad hoc. If you work in an organization, you might not know what GPUs you're allowed to rent for an hour or two, which ones are outside your budget. So, as a machine learning engineer, you've written your code, you just want to be able to deploy it and run it in a single click and produce a model that people can consume. Also, there was a lot of responsibility placed on you as a developer. Like, you were in charge of choosing the storage layers, which was S3 in the previous example, the reporting platforms, like weights and biases, and also it's in the code, or you would decide if we use GPUs or not. We don't want, as a machine learning engineer, we just want to focus on writing code. So this is where the centralized control system comes into play. I just want to caveat this by saying as well, some of the features here discussed are like a work in progress. And so not everything here is necessarily fully implemented as of yet. But so this is where the centralized control system comes into play. So the centralized control system we're going to discuss today is Versatile Data Kit. It's an open source project by VMware, and it's the project I work on in VMware as a software engineer. So what does Versatile Data Kit do? Well, it's made up of two components. There's the control plane, and there's the SDK. And we're going to first of all talk about the control plane. So what the control plane lets us do is anyone can write just a piece of Python code and submit it to the Versatile Data Kit control plane. The Versatile Data Kit control plane will take that Python code, and then based on the configuration parameters that the submitter submitted, we will create an appropriate Docker image and the appropriate Kubernetes YAML files, and then we will deploy it to Kubernetes on behalf of the machine learning engineer here. Then, obviously, Kubernetes is responsible for running the jobs. But all the while, Versatile Data Kit is monitoring the job. It will handle, reporting metrics into different systems about the health of the system. And also, if for any reason there's a failure or a success, the original deployer of the job can subscribe for notifications. So the benefits here are, firstly, separation of concern. As an ML engineer, my code gets running Kubernetes, which is what I want. But I don't have to focus on the Docker images or any of that stuff. I focus only on what I know. Secondly, there's no "it works on my machine" problems. A lot of the time, like if you're manually provisioning these GPUs, you might go into that GPU and set up a few environment variables, and you forget to document them, and then 6 months from now, it's really hard. If that for some reason is becoming your best model, it can become really hard to reproduce that because everything wasn't documented properly. But the fact that everything that is needed to run on VDK is submitted in one go, and it's essentially immutable. It's checked into Git. So if that's your best model and you want to rerun it, it becomes easy. There's no "it works on my machine" problem, and there's perfect auditability. We will always know moving forward, this model was created by this data set and created by this version of code using this number of epochs on this date. And so I think, if you were a machine learning engineer using this product, you'd be pretty happy at the moment in that, now I can just run stuff. If I want to run 10 training models with different hyperparameters, at least I can do it fast. But from an organization point of view, there's actually still a lot of downsides in this code. First of all, there's vendor lock-in here. The machine learning engineers hard-coded S3 here, and they've hard-coded the reporting platform as WMB. And it's not that big. And so also there's a very subjective naming convention here. I named it First Analyzer because it's my first review sentiment analyzer. But that won't really make sense to someone in 6 months from now. So we want much more, in an organization, you want a much more standardized approach here. It's good for both. It's good for the machine learning engineer and it's good for the organization, because as a machine learning engineer then, you don't need to find out these details. And also, there's another issue here. Obviously, you want stuff running on Kubernetes because it's kind of the status quo now. But pods in most applications that we write, we aim to make them stateless, and so pods are very appropriate for that. However, in Hugging Face, when you do training, Hugging Face actually pulls down the data set on the first epoch. and then it stores it on that machine. And so if you have to rerun a job with different training hyperparameters, or if your job fails for any number of reasons, you can restart the job really fast, and all the data sets and all the models will be already on your machine. However, in Kubernetes, that wouldn't happen by default. So there's 3 main issues in this code. Now, this is where the VDK SDK comes into play. It allows the configuration of all jobs to be managed centrally. And it decouples your jobs from your model storage layers and your reporting platform, your ML metrics reporters, and also from whether you want to use GPUs or not. So we'll go back to this code again. So now the machine learning engineer doesn't have to think, where do I save my model? All they have to do is say job input, get training arguments. And the VDK cluster supervisor can say that, look, we want to save all models to S3. We want the naming convention for where models are saved to be, team name, organization, group, and then we want the date in the path, and then the commit message attached in the path. Or the commit ID, maybe, to make it easier for someone to trace. Also, we were reporting the metrics into weights and biases originally, but we see that there's actually a better platform on the market now. We want to start using that, but we don't want to rewrite all the code in all our jobs. The fact that there's a layer of separation between the code and the configuration means that we can move provider without needing to rewrite any of our jobs. And also, it's in these arguments that you configure, like if you will use GPUs, even if you will use multiple GPUs. I'm actually running out of time. So there's a few other benefits, like I didn't get into the caching, but obviously because there was separation of concerns, Kubernetes admin can configure persistent volumes for your pods in which you're running this. If this is something that interests you, we have a Twitter account, which is VDK Project. Our open source project is Versatile Data Kit at GitHub. We would love if you guys would follow us. And if this is something that is interesting to you, please reach out to me. You can reach out to me directly at paulm2@vmware.com. And we did 2 previous presentations already at VMware Explore that you could check out. Thank you.
So let us start with our last session today. Topic today, network and security improvements with DPUs, data processing units. My name is Jörg Rösch, lead solution engineer for network and security at VMware. I'm responsible for the German public market. Usual disclaimer, so please take it into account. So, short my agenda. First, I want to talk about the industrial challenges. Then I want to talk about an overview of our solution with DPUs. Then I want to jump in the architecture, in the inner workings, how the DPU designed from the hardware perspective, and then also to the data path model behind. Afterwards, I will talk about some use cases, then about the installation part, and then I will jump to the current features which are supported currently with our distributed service engine. That's the name for the DPU support with vSphere 8 and NSX 4. Afterwards, hopefully we have some time for Q&A. Okay, what are the challenges today? I think, we talked a lot of on this conference as well. We have all this cloud native, Kubernetes, container stuff, which requires a lot of I/O traffic, volume, complexity, and so on. And on the other hand, we have that our security threats are evolving. This means it's not enough to have a dedicated north-south firewall in front of your data center, and you don't care about your applications inside or about your flows, because you have no clue about your application topology and also about the behaviors. On the other hand, we have not only VMs, we have containers, as I've already mentioned. We have DPUs, CPU requirements, GPUs, especially when we are talking here about the AI world, I would say. And this all ends a little bit in operational silos and complexity. So, how we can solve this? At the end of the day, we need a higher compute density and an accelerated security as well. So we need really a performant layer 7 security, and we need also to take care about security between containers, still to VMs, still to bare metal servers, and we need one management plane to establish this. Now I come to an overview. So here our usual x86 E6i host. What do you have currently before DPU? We have here all NSX services, switching, routing, firewalling, monitoring are running on the x86 itself. What we're doing right now with our DPU solution, we are putting these services to an intelligence network card. We're currently supporting the NVIDIA and AMD Pensando. And there's a slide you see here, DPU and SmartNIC. There's a slight difference between a SmartNIC and a DPU. A SmartNIC is designed for network performance. A DPU and a SmartNIC has only or is using the existing OS system. A DPU, which we are using, is a little bit different. It's broader. It's not only taking care about the network improvements, it's also taking care about security and storage as well. And what is also a difference, we have here really on the DPU a dedicated lightweight E6i image running, which is really designed for performance. Yeah, what are the advantages about this? We have a physical isolation between our workload and infrastructure domain, and this is especially in my customer area. I'm working here a lot for armed forces, military customers. Very important, because with this they can fulfill their regulation requirements. Okay, what are the other advantages? Yeah, okay, network performance, latency-wise, throughput-wise, and same for security. And the other thing is the visibility. When we are talking about security, you need some intelligence behind. You need to take care about every flow in your data center to have a whole picture. And what we can do with the DPU, we can directly analyze the flows. So you don't need any port mirroring or tabs, which are really complicated. With our E6e host, you can directly get the flows to your systems. For example, we have here a network detection response solutions where we really analyze day zero attacks and much more. And this is quite easy. Interesting point is, we free up the computer resources from the hypervisor, from the x86. And with this, it's really a topic for sustainability because we need less power consumptions and we need also less server mounts. Okay, I know this is really a little bit difficult to have there some calculations because it depends a little bit on your infrastructure, on your application landscape, and so on. But there's also a good white paper from NVIDIA who's talking about the sustainability topic. Okay, roadmap. Currently, what we are supporting is NSX services, offloading and accelerated to the DPU. Roadmap topic is we want to have also storage, vSAN on the DPU running, and in the future, bare metal as well. Okay, now I come to the inner workings. How's it running? Here you see a picture from a DPU card. On the left side, you have a management port. You have two production Ethernet ports. And the heart piece of this device is really the programmable accelerator. You can see here. CPU is ARM-based, ARM processor. And on the flash, there's really this E6E lightweight image configured. Below, you see some information about fast pass, slow pass. I come later on a little bit more in detail to this when I'm talking about the DPU, fast pass and slow pass and so on. How is it connected? So you see here our E6i motherboard. Here you have a connection from your DPU from the BCI level. And you have as well a connector on the card sitting here, which goes then over a daughter card to your BMC, to your base management controller for lifecycle management. Okay, now I want to talk about the data path model. How is it running? But before I want to talk about the DPU data path model, I want to show you how is it currently running with a usual VDS switch. So you see here below, what's going on? Now. Okay, excuse me. Okay, you see here, standard DVS switch. How is the data path model be realized? Packet comes on the physical NIC driver, and for every packet, you have a CPU interrupt and a context switch to the slow path. In regarding your routing, switching, firewall configuration, the packet will be forwarded or dropped. When the packet will be forwarded to your VM, to your vNIC, you have again an interrupt from your CPU and a context switch. And you know, especially with applications which have a high packet rate, you have a really high CPU load, and you're getting in trouble. This is a normal VDS data path model. Before DPU, we had also two different data path models where we can have a performant data path model, I would say. One of them, I think the old vSphere guys all know this, as a IOV, single root input-output virtualization. How is this running? Packet comes again on the NIC. We have always a handover between the physical function and the virtual function, and the packet will be directly forwarded. There will be a complete bypass from the x86 from your vSwitch, and your packet will be forwarded. So you have here really less CPU consumption. But the big disadvantage from this solution is you have a dependency from your vNIC pull mode driver to your NIC driver, and due to this, you cannot use any HA features, vMotion, DRS, HA, and so on. And I would say this is not really virtualization stuff. When you have this kind of vMotion, when I can remember the time when VMware has announced vMotion, this was really a game changer. And when you have your kind of solution without vMotion, it makes not much sense from my point of view. Then we have also another possibility. It's named Enhanced Data Path Model. This is coming with NSX. What we can do there, packet arrives here again on the physical NIC. We have a really dedicated CPU cores in polling mode for this solution. And every time when a packet arrives, the packet will be copied to a shared memory location, and the CPU constantly polling the shared memory location in a round-robin fashion. Then, when the packet information, the control plane information is available in the fast path, in the flow cache, the packet will be forwarded. When it comes the first time, there will be a mismatch. It goes again to a slow path, and regarding your NSX manager configuration, the packet will be forwarded, routing, switching, firewalling-wise. Then the packet will be forwarded, and the next time when the packet will be sent, the slow path has been updated the fast path, and your information will be available in the flow cache. Here again, when we compare these two solutions, on one side, SIOE pass-through, vSwitch, as I've mentioned, completely bypassed, no additional CPU load, very good from a performance point of view, but you have the disadvantages from the hardware dependencies and from the HA features are not available. On the other hand, enhanced data path. One point is also it's a little bit more difficult to install. You have here the NSX configuration. It's not quite easy to implement the EDP path, but it's not bad. It's better from, you have some CPU load, to be honest, sure. But when you compare to your normal VDS mode, it's much better. Yeah, and all these HA features are available and so on. What we have done right now with DPU, we combined these two modes to a real performance mode, and we have also then the DPU acceleration in hardware. How is it running? Here you see below the DPU card. Packet arrives, then we have a hardware table. Decision will be made in hardware. That's the most important point as a takeaway. And when the information is here in the hardware table, packet will be directly forwarded. If the information is not available, we have again the EDP path. So, packet will be copied in a shared memory location. CPU is constantly polling the shared memory location around robin fashion again. And when the information is there in the flow cache, packet will be forwarded. If not, it goes again to the slow path. Regarding your NSX manager configuration, routing, switching, firewalling-wise, packet will be forwarded or dropped. Next time, no wonder, I would say, slow path has been updated the fast path, and the fast path has been updated the hardware table. Decision is then in hardware available, and the control plane function is sitting here, and when your packet arrives, decision will be made in hardware. This is the emulated mode, which I have described right now. This is the default mode. So it's a little bit complicated. We are always good at VMware with renaming different things. Probably you will see this also as max mode, because at the beginning when we have announced it, all this DPU stuff comes from a project Monterey. And initially we have named it max mode, but we have renamed it a few weeks ago. It's emulated mode right now. Same, unfortunately, is here for VM Direct Path. We name it now VM Direct Path, but usually you often see here UBT v2 mode, Uniform Pass-Through mode. And you see also in the GUI UBT, because this mode is also an option for high-performance VMs. You can activate it, and then it's a formerly SIOE mode with a completely bypass from the vSwitch, from the x86. And how you can activate it, you can go just to your vCenter, you can go to your VM, you do a check mark for UBT v2, and then the mode is activated. And you can use this feature right now with all HA features available. That's the biggest advantage from this solution. So you have these two possibilities. You have the default mode, where you have already hardware acceleration, and for really high performance workloads, you can activate it on your VM here, the VM Direct Path mode or UBT v2 mode. Here again, I compare these two different modes which are available with a DPU. On the right side, VM Direct Path or Uniform Pass-Through mode, near zero CPU consumption, complete guest memory reservation, requires an VMX Net 3 version 7 driver, very important, high performance, low latency data path model, And what is also important point is here, UBT, VMs, there's a limitation. When you have virtual functions, you have always a limitations per NIC card. You can have 256, 512, whatever. You have to check this. There you must be a little bit be careful. But usually you don't activate the UBT, V2 mode or VM Direct mode for all VMs in your environment. So usually you don't have any issues with this. And on the other hand, we have the emulated default mode. As I've mentioned, less CPU consumptions when you compare it to a usual DVS switch. No guest memory reservation, no driver dependencies at all. Performance accelerated in hardware again. And we have with this a higher workload density. Now I come a little bit to use cases. Yeah, okay. Use case, distributed firewall, distributed IDS, IPS. I think all of you already heard about micro-segmentation. So I will go there really quickly through this point. What we are doing here, let me check. Sure, with distributed firewall in common, we have a single management plane. We have no dependency to any VLAN structure, overlay structure, whatever. What we can do here very easy, when we want to secure communication between VMA and VMB, which are on the same network, it's no problem for us because our policy is sitting in front of the VNIC. And we also support the container with distributed firewalling. Sure, it's a little bit different. You have to work with tags and so on, with objects, because you have no real VNIC. But what we can do with the solution here with TPU, we completely can offload and accelerate the distributed firewall function here to the DPU. For IDS IPS, it's currently in a tech preview, to be honest. So it's not fully supported right now. It's not on our roadmap. But distributed firewall is already fully supported. And we have done there also some really significant tests with one German armed force customers. We have their white paper, which is already published 2 days ago. So you can have a look. It's very interesting because you see there in this document that we can put much more firewall rules on the VNIC level, and you have a much better performance, especially when we are talking about distributed firewall and our security solutions. Yeah. What is also important? I don't know. Yeah. It's not a V2T migration, I would say. You just go to the vCenter admin, just uses the vCenter, just creates the VDS switch, just can add the uplinks and so on. There's no change at all from the management plane perspective. It's more the hardware change behind. There's a lot of intelligence in a DPU card, that's for sure. But it's no hardware, only a hardware change, excuse me. Everything would be done from the vSphere administrator still on the vCenter level. And for the NSX manager administrator, it's the same. You still go to the NSX manager, do your routing, switching stuff, and so on. Currently supported, what you must is also important, which server vendors are currently supported. We have Dell, we have here HPE and Lenovo. We have other vendors on the roadmap as well, but this is the current stage. And from the DPU perspective, we have currently NVIDIA supported, AMD, and Intel's roadmap. So these are the 3 vendors where we are currently working about. Now I come to the installation part, how we install this kind of solution. So the first thing is you roll out your usual E6i image, and your DPU card will be automatically detected. You do a check mark on your DPU card, and then the E6i image will be rolled out to the x86 and to the DPU in parallel as well. Second step is that you create a VDS switch. There you also choose NVIDIA or AMD Pensando card. And the third step would be that you do the E6i or the NSX VIP rollout with a life cycle manager. And the last point is that you have the option for high performance requirements to activate the UBT V2 mode. And that's all. So, what is currently supported? So we support currently overlay, VLAN-based segments, routing, switching, as I've already mentioned. As I have also mentioned here, distributed firewalling is supported, and IDS IPS is a tech preview. Here, okay, some normal stuff, visibility, operations, trace flow, IPFix, and so on. And here, again, the Bluefield 2 card from NVIDIA with 25 gigabit and 100 gigabit, and also with 25 gigabit and 100 gigabit for AMD Pensando. Then scaling-wise, we currently only support one DPU. That's also, but it's on a near roadmap, I would say. What is also interesting, we have announced, I think it was yesterday or 2 days ago, VCF 5.1, and with VCF 5.1, we also support their DPU as well. Key takeaways: NSX is offloaded to the smart card. Yeah, the hardware acceleration, no change at all from the UI perspective, from the administrator point of view. Same UI, better security performance, and also sustainability. That's the most important points which I wanted to address today. And here you see some resources. As I've already mentioned, we have a white paper with BWI. We have also on YouTube from our technical product managers a lot of interesting videos about this. There's a playlist around this. You can search for this very easy. You can find it. And there's also an interesting documentation from NVIDIA about the sustainability. It's not based on our solution, but it's usually not mandatory. It's common, described there, DPU, what you can reach, how you can reach there, and power efficiency. Okay, also interesting, okay, everything is recorded. We have the last session today, but maybe you can have a look afterwards when you're at home. There's some really interesting sessions from NVIDIA, from AMD, from our side. You can have a look at this after the conference. Okay, with this, I say thank you, and I wish you really a nice trip home and have a nice time.